All right, so I'm running a little bit late today. I was getting a quick refresher on some topics with Milo before I started today, just to make sure that I was, up to date uh, with this stuff. Because I have to admit, even though I have been working pretty deeply with the signals stuff for years, I have been down a pretty specific tangent the last several months. I think many of you are aware. And sorry, my second monitor just crapped out the second I started the stream here. Give me a second here on this technical stuff. USB, no signal. That's lovely. Come on. All right, is it back? All right, there we go. Sorry about that. Oh, okay, it's gonna be fiddly today. That's lovely. Okay. All right, we're good. All right. Yeah, I'm streaming today at an earlier time than usual. Just changes. Have a new baby. Got kids to drive around to, etc. So yeah, almost fooled you with that background. Yeah, I fool everyone. I mean, it is my office. It's just my office from a different angle. So yeah, but green screens are fun. You can do stuff like this. Looks like anyway. How are we doing? Yeah, sorry, a little disorganized because it's been a while. It's been a month since I did the last stream, and this gives people some time to sign on. We get to let people get past their Twitch pre-roll, because I'm sure all my Twitch subs have expired by now. So there's that as well. Let me actually pull up Twitch here, make sure I can interact with you guys in the chat. Yeah, Twitch chat is existent. All right. There we go. And we probably should let people know that we're live here. All right. I don't know if people like the thumbnail today. I had quite a few different references in it, so hope everyone got that. Obviously, the Alien from Resident Alien. I don't know if anybody watches that, but Alan Tudyk is hilarious. Big fan, always been. And then I took the logo from the Aliens movie. So it's all good. Anyway, I think I've wasted enough of your all's time to actually people join the stream. Looks like they completely updated StreamYard. Lovely. Okay, so to the topic today. Yeah, that's not it. That's not what I'm looking for. Let me see if I have notes. Yeah, okay, got my notes. Okay, sweet. I took a few because I wanted to, make sure that, even though I admit this is about as much of a first look as possible, I was at least a little bit prepared for references. We're going to be talking about alien signals. We're going to talk about some Vue stuff, Vue Vapor, I just saw Evan's talk from View Conference. Might want to talk about that a bit because I think we're going to talk a lot about benchmarks today and the concept of performance. Um, because I think this is pretty important for people to understand, and I think it gets misconstrued all the time. I was someone who's suggesting that benchmarks are primarily a marketing thing, and I'm like, not by my book. I do everything by benchmark. There's actually, while I was away, there's some term like vibe coding that started showing up, and I was like, "What the hell is this vibe coding thing?" And I looked it up, and I mean, it makes a lot of sense, but it's kind of funny. It's like the exact opposite process to what I do. Like I sit there and write like a billion pages of notes and thoughts before I can figure out how to even approach the problem, and then I do tons and tons of benchmarks to decide if something's even viable. And then I go, okay, what can we do with this? Whereas, like, that's the opposite end where you're just like, I have an idea or a concept of an idea, and I'm just going to kind of guide my process until I find where it is. Um, yeah, it's like two opposite ends of the spectrum. One's very much a design product zone, and one's very much like a engineering, mechanical kind of zone. And I think both approaches are valuable, like top down, bottom up, for different kinds of problems. So it's kind of interesting. But I rely so much on benchmarks that when like the prospect that, you know, they're a marketing tool is just craziness to me. Anyway, I get it, but like we'll talk about through the course of the stream. You'll see what I'm talking about. I'm pretty sure. Anyway, yeah, it's nice to see everyone here. Yeah, so I usually tell everyone to say hi in the stream at the beginning, and then I give people shout outs. You know, people like Aiden, Creator Million. You know, and great people working on Solid, and yeah, I see a lot of regular people here. It's great to see you all. Sorry, I kind of was dealing with my technical issues. So just hello everyone. Great to see you. So, yeah. Sorry, did I already say hi to Greg? Hey, Greg. This is built by people who definitely are not vibe coding. Yeah. Hello. Okay, so yeah, let's see if I can. It's probably been so long that my Mac's going to tell me that I need to like restart to share my screen. I'm not looking forward to this. Let's see if I can share my screen without it doing it. Oh, I can. What do you know? I can. Thank you. Okay. Yeah, I mean, I should have banners. I, I, I've been trying to keep up on like the subtitles. There's Jesse. I don't know if you guys know Jesse Pence. That's done an amazing job for over a year. Basically putting in timestamps for all our um, uh, streams. And then I took a lot of time off and spaces, and I think we kind of lost touch. So I've had to do the last few myself, and God, I do not enjoy doing that again. It was really important for me to do it for the Solid 2.0 signals stream, and it took me like 4 hours, yeah, like half a day to get all the timestamps in, and I haven't even got to doing them on Tanner's stream yet. So I mean, if I was smart, I'd add banners to kind of help with this, but I don't know. I think we're just gonna flow this organic. So here we go. It's funny, googling alien signals, and this is what I end up with. Let's get to it. First of all, I did not realize Aliens Signals was sponsored by StackBlitz. Apparently, the developer is sponsored by StackBlitz, which is kind of cool. Just an aside note, I love to see when startups help open source projects be able to, help developers be able to do this. And I mean, it's important so that we can actually fund important work to happen. What? Hey, what? Well, alien signals. Yeah, let's get started. What are alien signals? I think this is a perfect header. I don't need banners when I got DAX. More than this cute logo, they are a implementation of push-pull reactivity of signals, and inspired by many other projects apparently here. Let's look at the README here. Propagation algorithm based on view 3. Not really sure what that means. Maybe we'll find out. Preact's doubly linked list approach, or signal boosting. This I am a little bit familiar with, but if you're not, it's fine. We'll look into it a bit. Inner effect scheduling of Svelte. I've heard about this. I'm actually not super familiar with this one. And then the graph coloring approach of Reactivity, which we have covered previously on stream. Milo, obviously solid core team member, wrote Reactively, and we had him as a guest at one point. And he wrote a great introductory article about Reactively and showing all the different ways of notifying, right? And so this is a bit outdated now, but it gives you a good idea. This blog post is still to this date one of the best reactive activity, like more advanced. Like I did that, how to write your own reactive library, a very basic one. It's not even, I feel like it's like good for teaching the concept, but it's like kind of almost a lie. Like 90% of the complication of reactive libraries and signals libraries is in the implementation of derived values, computeds or memos or whatever we want to call them. And when I make a reactive system in 30 lines of code or whatever, 40 lines of code, it basically just has signals and effects. It's just a pub sub that I've warped into has auto tracking, but warped into the shape of our signals libraries, where the real power is the way that stuff propagates through the graph. And he talks about this a bunch, talking about like versioning and reference counting, and these guys use versioning if I'm right, and then coloring. So it sounds like you use coloring reactively. It sounds like the author has definitely learned from the different implementations. I remember, signal boosting. We should probably talk about this one a little bit. And this again is another good blog post. I never remember if I could say his name properly. Joking. I met him a couple times a couple years ago when he was working on this, when Preact Signals implementation coming out, and he had a bunch of questions, and we kind of compared notes. And one of the big improvements in terms of performance that Preact Signals made was how it handled managing the dependency graph, like the actual. It's not just the notification. Reactively focused on the propagation, but the actual data structures of how you actually hold the dependencies is an interesting problem. And I don't know how deep we want to get into this on the stream, but I mean, you guys are here and I'm here, so we can talk about this a little bit. But okay. Some people, when they get interested in signals, the first thing, you've heard of the Gang of Four and the observer pattern. Let's see if we can see here. This is the basis of all signals libraries. Knockout had it, and it was like established as one of the 23 well-known Gang of Four patterns. Right, there's a subject and an observer, and there's this relationship between the thing that listens and the thing that is being listened to, right? And the problem with the observer pattern in general, it's not a huge problem. We have ways to solve this, but it's like things that discouraged this in the past. Why, one of the many reasons why the React team doesn't like signals is that the life cycle of the observer and the observant, I don't know, use these terms, can differ, right? So so what they say, the observer pattern can cause memory leaks known as lapped listener problem because of basic implementation. It requires both explicit registration and explicit deregistration, as in the dispose pattern. And what they're talking about here is it's possible for the signal, like the source, the thing being observed, to outlive the thing listening to it. And over time, it just keep on collecting more observers that just fire off into space. No one cares, but you just keep on leaking memory. Observy. Observer and observy. Is that how we're going to call it? Okay. So the reality of how to solve this is you can't actually just hold the value in one direction. Like you can't just be like, I have because like the naive approach, and if you write this by hand when I talk about that 40 lines of code, actually, do I have this building a reactive library from scratch? All right, okay. The naive approach is your signal is going to have its list of subscriptions, and then when you write to it, you're just going to go through that list and call it. But as I said, how you have a bunch of things listening, how do you make them unlisten, right? One of the things with the our typical auto tracking reactive systems is that you don't have to manually call subscribe, right? You just go effect or computed, and you just listen to the signal, and you're good to go. And there might be on the outside, like your effect might have like a stop or dispose kind of mechanism, but like generally speaking, how does that work? Well, the answer is you actually have to keep the references both ways. It's not just the signal or the observee or observable. You guys are great. Yeah, that needs to keep the list. It's actually the observer also has to keep the list of the things it listens to, and that way they can, like, when the observer goes, I'm done, it can go back to the things it listens to and goes, hey, unregister, 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 right? So it's kind of a fundamental problem that you actually have to link both directions. But if you link both directions, I think you guys should realize the consequence here is these things can't self-release. Like they the one reference the other reference one, as long as one exists, they basically have the potential of never being garbage collected. So yeah. I mean, why not subject? Because that's literally what the term they used when they were talking about it, the observer pattern. Why is this relevant? Well, it means that managing this list is always going to be a critical core bottleneck or piece of the performance when looking at signals. And in the past, like way back in the day, like go back to like Knockout, this is a very simple setup. We just had arrays on both sides. And honestly, when we were tracking, we probably didn't dedupe, or at first people literally just kept on pushing stuff to arrays. And the problem is, like, they get kind of big. You just blow it out after every run, and you just create these arrays. And if you listen 5 times, you'll have 5 entries and all this kind of stuff. And people did try and start doing smarter things. They would be like, whenever a new dependency come in, they'd be like, hey, is it already in this array? So you do like a find operation. Well, it turns out that's like really, really slow. If like every time you do some kind of tracking or some kind of update or something, you're sitting there and doing like, is this in the array? Is this in the array? Is this in the array? Is the array, if the array grows, or if you're just simply like asking the question over and over again, arrays are actually kind of slow. And this led to, and as I showed in our kind of basic example, people using sets when they were available. So sets were better because now you could just like make sure that it was in there once. And at the dawn of like Vue and MobX or that, this is kind of where they kind of came in. The problem is sets are fast for lookup, but they're slow for creation. They have this memory overhead. And as I said, when you're making a basic example, you're going to use sets. But the reality is it had a significant kind of performance overhead. To the point that when I was looking at reactive libraries, like I built my own with naive arrays and all this stuff. And when I started looking at how I was going to do stuff performantly, I looked at Vue, I looked at MobX and stuff, and I was like, okay, but then I realized, like, I saw other libraries that come out and they're way, way, way faster. I'm like, what's going on? And one particular library came out, and that was called S.js. And if you look back to S.js, it was actually created like in 2011 time period, like back in the original knockout days, kind of like went on its own parallel path. But S.js had kind of come up with a different approach. Instead of going to sets, they'd improved the array approach, which seems kind of crazy, but by adding more arrays, which is what they did was they added Milo affectionately calls it slotting, but the idea is not you don't only store the items in an array, like the depths on both sides, the dependencies and the listeners, like you actually also store the index of where it is in the others list. And as long as you have both pieces of information, both the observer and the index and the observer, you don't have to do those expensive find calls anymore. It doesn't stop from deduplicating entries, but it means that like on removal, you don't have to like go searching for it, which as I said, the buildup and removal was a very, very common thing here. So S.js drastically improved the performance of these reactive libraries at the time. And since then, there's been other approaches where it's like, oh, maybe we don't have to always reconstruct the list or whatever. Anyways, fast forward to the future. What Preact introduced was, what if instead of using an array or a set, we used a linked list? Right? And we'd look at the edges. And there's been lots of versions of this over time. And I think a lot of experimentation over the last 2 years has been actually understanding the implications, because a lot of them were actually like did things that seemed good at first, like, oh, let's add versions on the edges and do this, all these kind of smarter propagation pieces. But then over time, I think what's kind of we've seen happen is people go, oh, actually not doing the thing that we thought would improve performance actually improves performance. Like it's actually been a reductionary thing. And I mean, this is one of the things I love about S.js, because they just sort of like, we're not going to dedupe the array. Like sometimes it's okay that things get added multiple times. It's faster than actually worrying about it. And this is where I'm gathering what we're seeing kind of come to fruition here with alien signals, where like I used to have a benchmark where I'd like try and compare all the different approaches. In Solid Repo, you'll see like the bench folder, and I had like all these different kind of propagation and different kind of patterns here. But over time, I actually had to break off a separate, what I call core version of Solid, because Solid had gotten so complicated with transitions and all this other reactivity stuff that I kind of had like a baseline version that I would mutate for my benchmark purposes that was different than what Solid actually used, but basically the same algorithm. So anyways, let's continue a bit more with alien steroids. We impose some currents, such as not using array, set, map, and disallowing function recursion to ensure performance. I'm gathering they mean internally in terms of data structures, not in terms of what values you can hold inside the signal. I think I saw someone say like, how is this at all useful if you can't use any of these? I think they actually mean that they don't use arrays, sets, or maps in terms of internally to prevent, this overhead. Yeah. Yes, it's internal. Yeah, that makes sense, because I mean, you definitely want to be able to track arrays. That's pretty fundamental. Civility and more recurrence within complex scheduling strategies. Well, we'll talk about this. I think then yes, I think it is important. I think this is I think this is just a way of paraphrasing what I was saying a minute ago, that some of these like versioning or more complicated scheduling strategies actually are more expensive than coming up with the right way to store the data and just running it out that way. Even though Vue 3.4 is already optimized, alien signal is still noticeably faster. Okay. Oh, come on. Really? I can't just open this image? Oh, okay. From the transitive bullshit. Yeah. It's funny. Milo reactively wrote this benchmark, but then it looks like when alien signals came out, someone forked it. I want to talk about this benchmark for a minute here, but we'll get there for a second. So basically, 3.4 switched to pull based, similar to Preact, and then wanted to continue the work. Like, this has been probably the most exciting thing about what's been going on recently, is like people kind of get a taste for it, and then they keep on. They're like, oh, there's room to improve. They move the room to improve and room to improve. And I think we're probably getting to a pretty optimal place. I want to look at this in a minute, but then yeah, obviously Vue's using it. Okay, basic API. So we have signals, derived signals, effects. Yeah, straightforward. Effect scope. Cool. Okay, so right off the bat, this has effect scope, which if you've used Solid before, is create root. Essentially, they add ownership like S.js. So already this is more than like a basic implementation. Like, and it has effects. Reactively doesn't actually have effects. So reactively was just signals and computeds. So this is actually, as a baseline, I don't know, what I call signals 1.5. It has the ownership graph. It has the ability to. It has the effects, which means it has some amount of scheduling. And okay, and then yeah, create signals proposal, blah blah blah. In order to eliminate recursive calls and improve performance, we record the last link node on previous node to propagate the trend, implement rollback logic to return the node. So all in this code is difficult to understand. You don't necessarily get the same performance improvements in other languages, so we include the original. Well, that's nice. I like this. The mentality here appears to be like, this algorithm should be implementable cross platforms. Like, basically, they're like, look, we want. And I mean, I saw that above here when they were talking about like in Go, or Dart. So like, there's definitely a desire here to keep this implementation generic. And it's very interesting to me that ownership has finally found its place as part of a core library. Like, this is one of the things that I've been talking about for quite a long time, like, because ownership is very, very important to how we do rendering in Solid. It was like basically the big advance that S.js added to these libraries about, as I said, about 13 years ago. But almost no signals libraries other than S.js through that decade, until I guess like when Solid came out, actually added ownership. And it's a very, very, it's now kind of like a keystone topic. It'd be weird to find a new signals library that didn't have a concept of ownership, I would think. But I don't think Preact signals have ownership. So I'm actually very stoked to actually see ownership as part of the implementation here. Yes, yeah. I mean, I'm not saying everything's on a single path. I mean, I'm just saying that S.js went on its own path. They used a different algorithm for arrays that was faster. Yeah. I mean, the funny thing is, there's a lot of historically, there's been a lot of really powerful research in this area, but it just hasn't been mainstream. And now it's starting to be. So like, it's interesting to see like, like the implications that have like actually lots of people working on this. Like, I'm not going to lie, I would love to see a modern take on SJS in terms of this. Like, this link list approach might be fast, but I mean, there's different types of benchmarks. The thing that SJS nailed was creation time, and as everyone knows, linked lists are really good for in the middle updates. But I have to imagine that a slotted approach maybe would still be faster for creation if updated. Like, I'm sure there's greater minds than me that could probably, make that happen. I'd be curious. We'll look at the benchmarks in a minute. I just want to kind of go around a little bit further. Yeah, is this the end of it? Okay, yeah. So this is the end of it. Yeah, no, I do think it's cool though, like that. The idea is this is something that could be implemented in any language. Yeah, so I mean, sets did not exist in 2011. Yes, I get what you're saying. I'm just saying, like, everyone was doing really dumb stuff with arrays. S.js was doing smart stuff with arrays, and then when the time came, most solutions moved to sets. S.js stayed on their smart solution. Wait, how did the linked list? Linked list is the hidden solution here. I believe so. Yeah, let's take a look. Let's now is probably a good time as any to take a look at the code and get an idea of what we're looking at here. So first thing I noticed, and this is what kind of made me want to cover it, like because people are like, oh, look at alien signals, look at alien signals. And I was like, it's faster. You'll see later in the stream why I'm like, but I think if you actually read the README, it's not about the speed. It's about this trying to simplify or like, and I say simple not in the terms of like easy to understand necessarily, but in terms of like I'm hoping like clearly defined, elegant code, because this is a very small a fairly small implementation. I looked at it and I was like, wow, index is literally the API surface. So like for the most part, you see it just importing stuff from system, and then what do we have here? Create reactive system. Okay. So this is where it injects tracking system. Yeah, this is like the actual like run function, so to speak. Start tracking, try to do the thing, end tracking if value is not equal. So if you want to add equality checkers or some other kind of thing, if his scope is notified. Interesting. I don't know what this means, but this has to do with propagation, pause stack, start batch, end batch. Okay. Pause track moving fair. I always found it weird that the Vue community doesn't use an untrack function and they have this like arbitrary like stop start. I mean, maybe because it's designed to be an internal API. I brought this up with Evan at one point, but like having you the pause or start without the beautiful thing about what untrack function is, it scopes the range at which this thing operates. You can't stop without forgetting. You don't have to reference count like how many stop calls or start calls. You know what I mean? Like conceptually, like if you're nesting, like you literally have created the scope. Now, that being said, you created a scope, so maybe the extra function call is a consideration here. But like there's lots of situations where, especially when you get these nested hierarchies, where you actually want like the reason that components are untracked and solid, or the top level of 4 iterations untracked, where you actually like when you're mapping over things, where you don't want to just track everything underneath, you actually want to like give the end user like, here's an untracked scope for you to work within. So like tracking and untrack is very fundamental. It's always been interesting to me. I mean, this is a thing, and you can build untrack using this, whereas using untrack you can't build this. So in the sense, you could say this is more fundamental, but it's also like kind of error prone if you expect end users to use it. The array index data structure you're talking about is sparse sets and used all the time in game dev. Yeah, I mean, I definitely can see it, and it's it'd be really funny if we see another bounce back around to that. I honestly always thought S.js was really onto something. Anyway, yeah. So signal, use, bind it. Yeah, that's fine. Computed. Yeah, a lot. You'll see this a lot where this is just a sort of like side note. And when people ask about the TC39 signals thing, I want to kind of point this out to people. A lot of times when you see signals libraries, you're going to see something like this. You're going to see like some internal core system with like a lot of stuff, and then you're going to see this interface that's like some object being bound to some like specific accessor kind of thing. And the reason is that like the awkwardest thing about signals in general is internally we always want access to more things than we want to expose externally as an API. So like it makes it adding signals to the platform actually a little bit challenging, because either you try and make them user friendly and you but which is kind of confusing if you have like a bunch of different concepts and you kind of like it gets a mess, or you kind of make them knowing that someone else will wrap them. And that's what most of the framework authors who worked on the signals proposal were doing. They're like, look, we want a primitive so it can be shared, so we can build them, like debugging to the browser, and we can have like the same kind of concept of propagation. We can use the underlying C+ engine or whatever to improve performance and all these kind of aspects, but not as the API wrapper, because we understand like whether you're Svelte with runes, and or views API or solids API or whatever, we understand that we don't want to expose like all these internal things, because the actual like signal node or React node underneath is like, it's got like 15 properties on it. It tends to be, I mean, this implementation might be different because of the link list. Maybe the link list or the links actually carry some of the properties with it. But my point is, like, I think it's pretty common to see like this surface face over the actual implementation. So the issue is a lot of the time L1 through cache inline arrays until you get into the thousands is faster than sets. ON depends on node. The real problem in JS, you have no control over the underlying arrays. Fair. Yeah, I mean, it's kind of interesting though, because you don't actually expect to get into the thousands in the case of depths. Most signals or like compute parts, nodes in the graph, are going to have like one dep. Most. Although I guess the reverse isn't true. What you find in UI is that you fan out pretty rapidly, but like each of the fan outs might depend on one thing or two things, like a low number of things. But conversely, the source is dependent on by maybe 1,000 things. So yeah, maybe it'd be interesting if different sides of the edge were optimized for different things. Anyways, it's just a thing. I've been looking around the UI and to do real things in S.js. Interesting. Okay. I mean, it's hard to say. And one thing that I've been finding a lot, especially working Solid, which is confusing, because we have debug tools. I don't know if you've seen the dev tools for Solid, because we didn't have components, right, or a VDOM. We've been in this sort of ownership graph thing for our whole existence, basically, And so our dev tools actually show you the whole ownership and reactive graph. You can actually see the whole thing, like in terms of like, reactivity, but it's like a bit like walking into the matrix where like, all the green numbers are coming down the screen. Like there's so many things, and like some constructs are composed of other constructs. Like if you look at like control flows or like suspense or stuff, you might, or air bounds, you might have like 5 of these things working in tandem with each other. So like the graph gets kind of complicated to kind of go like translate like this single concept into like, multiple primitive nodes that talk to each other. So yeah, I'm honestly not sure, but there are certain characteristics that you can see emerge in programs simply from the shape of the problem, so to speak. I can't tell you how many because that would scale with the size, but you can tell kind of by the shape. Okay. Getter, bind the getter, that makes sense. Effect. Yeah, and then here, yeah, you can see the ownership here, right? We have sub. Yeah, okay. Oh, sorry. So this is tracking, and then this is tracking and scope. Yeah. So they call scope, I think, is ownership, and then they call sub dependencies, if I'm understanding this. If you look in, you can always tell a library. Yes, the active sub, active scope. There's always a global variable in reactive libraries, and the common one that we always first learn about is the listener or subscriber or whatever they call them, subs, observer, whatever you want to call this term. But you can tell when something has ownership because there's a second one. We call it owner, they call it scope, but same kind of concept. Do you have any updates on Tuesday? Honestly, I used to go to the meetings like we had a public meeting every second Tuesday, and then we had an internal meeting every second Tuesday once we put the original proposal out. After about 2 months, most of us stopped going to those meetings. I sat in a couple of the public ones and I kept the private ones. I had some like interesting chats with some other framework authors, especially, and then the public one trying to like gauge people's interest and understanding. Like they're still going. People are still pushing it forward. What I was talking about was basically the starting point when we recognized this almost within the first week of the framework authors getting together before the proposal was even pushed out there. It was kind of interesting because other previous observable like for RX style observable proposals had all been about interop. It is all about the public API service, right? Because you have operators that need to operate. So we had like Ben Lesh in there, and he was really wanting this to be a user friendly mechanism. And he was like, it's all about interface, like symbol, signal, or whatever, like that kind of mentality. And he was kind of outnumbered. And I think after a week or so or two, he was like, I think he got in and he kind of changed boat on our side. And he was like, yeah, okay, yeah, that makes sense. And kind of got there because of like, you talk to Misco about presumability and its needs. You need access to internal parts of the graph. You can't just like hide it. But on the other hand, nobody wants to give that to the end user. So, like it's awkward. So yeah, most of those discussions were behind closed doors. It's why the proposal was made the way they were. I know that there's been discussions like that since in it, because like when the web component and lit people and all of them came in, they're just like same thing again. They're like, why doesn't this just work as an end user API? It's because like it's tricky. And if you have like, this is designed to implement a system. It's not designed to have like every different web component have their own reactive system all sit next to each other and have their own thing, because you kind of want the schedulers to play nicely together. But we didn't want to include scheduling because we didn't want to make too many assumptions on how scheduling should work. So it's like, because even across the frameworks, we couldn't decide on that. So like, yeah, I mean, this one's interesting. I hope that we can keep the scope small enough that we can find real value on it. But it's always very challenging when people who like web components are involved. Anyway, sorry, where was I? Okay, a lot of standard questions here, but I'll answer one. Do you think it's worth doing the standard? The benefit here is potentially worthwhile. There could be performance improvement, which is key, but the key thing that I'm actually excited about is, think about async await in the browser, right? You can see async stack traces in the dev tools. Like you can actually walk through it when you hit an await and continue on the other side in terms of debugging. Signals debuggability is one of the challenges we have because it's an observer pattern. Things can fire all over the place. MobX has done an amazing job on this kind of tracking. They actually like almost make their own call stacks. But picture if, because this was core, this is part of the JavaScript, we could actually trace reactivity in the same sort of way. I had talked a lot with the guys from Replay about potential of doing this, like time travel, like moving back and forth between reactivity. Because there's the challenge with the reactive system is, while there's a cause and an effect, when you're actually tracing through the code that runs, the causality is completely lost. It goes from being like thing happens over here to like whatever linked list propagation scheduling, whatever notification coloring, whatever thing, to something over here executing. And as someone trying to debug that gap, it's increasingly difficult to actually like piece it together. It would be amazing if that was just something that you could do in the browser. That's my biggest sell. I mean, I understand there's a lot of complications and a lot of other pieces. I'm constantly concerned about the impact of future APIs. Like the standard doesn't have scheduling. It doesn't have ownership. You want to make sure that ownership's part of it. I think everyone kind of now agrees that ownership's an important part. Well, what about async? Again, this is an area that's, very important to me right now, but I don't know, it's going to take time. We're still learning this stuff. And the worst thing you can do is put in something to standards that is not ready. Otherwise you get stuck with it and then you're kind of stuck, as again, like web components. Yeah. Okay. Computed, notify, scope. Anyways, on the surface area, effect stop, start tracking and tracking. That's interesting. Oh, that's so clever. Sorry, this is just a funny thing. Do you understand what this is? What this is doing? It 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 it's reusing the internal cleanup mechanism, because what it's doing is it's starting tracking, then it's ending tracking. It's for this node, which I guess is an argument for the. Oh no, but this is pause and resume. I, I I hope you get what this is doing. It's basically saying, hey, start tracking on this node, and then don't track anything and end it, which means it automatically disposed of its dependencies because they created it runtime. I'm gathering that's what this does. It's kind of cute. Getting into Vue and people trying different stuff. People were looking for that de facto signals library for a while. In fact, people were pressuring me for a while. They're like, "Oh, you should release solid signals," and I was like, "It's not that good. Like, I mean, it's fine, but I hacked together what I needed at the time." You have to understand, like, when I wrote solid signals implementation, it was after I'd kind of migrated from the S.js one. It was like 7 years ago. Like, it was fast. It wasn't as fast as S.js. I needed features that S.js didn't have, and it slowed it down. But like at that time, most implementations were actually all really, really slow, so I didn't really care about it. But I think people have been like, after Preact and all this new thing, people are looking for the de facto push pull stuff, and I think we're finally getting to where this is a very reasonable base for reactivity as we know it yesterday or up to today, so to speak. Right? Like that's what I'm gathering. Well, the interface here side isn't that interesting. So let's look at the system here. And I think the first thing that come out is this is about 500 lines of code. So, and there's comments and stuff, and like this is not a big implementation, which is cool. So let's take a quick look here. As I said, I'm not an expert on this on any hand, but just this is my first look, so let's like look into it. So yeah, it's interesting the reactive system has the run and I guess the notify mechanism injectable. I think that's smart. And then it uses that to build the rest of the stuff out. Okay, and what do we got here? Links a given dependency subscriber if they're not already linked. Fair enough. And this is just like typical. I don't know how they do it, but depths tail, subs tail. Yeah, so are they, I guess maybe they're using like the same. Are there, yeah, there's two lists. Yeah, there's a depth link list and a sub link list. And then they're basically just doing link list operations of appending. Okay. Propagate flag should notify recursed is valid. Okay. Interesting. There's recursed and propagated. So I'm gathering there's some optimizations in here in terms of flags. I'm not used to seeing necessarily all those like notify tracking. Okay. There's more flags here than I'm used to in terms of the basic pending effect pending. Okay. Yeah. Because there's always like, usually like with coloration, there's and even version 200, there's the definitely dirty and the could be dirty and clean. There's like three states typically on a reactive system, right? Because when you propagate through the list in the push pull system, you need to actually notify everyone at the end. So you have to go through, and the thing at the beginning is definitely dirty, but all the way between that and when you actually pull it all the way through, the thing may or may not be dirty. If you assume that it's dirty, that's the problem with push only algorithms. They kind of have to. Well, I mean, it's not really the problem with them. I mean, their problem is over execution. The problem with push is that like you basically go down and you execute as you go down. And the good thing is if you ever hit something doesn't update, you shortcut and you're done there. But you can't see the whole graph. When you do pull algorithms and you assume everything's dirty without the push, like React, you basically have to re-execute everything. Sure, you can memoize, shortcut it, but you basically have to check every single thing and be like, okay, I can't stop early. Push pull has some of both characteristics where you push through and you go, okay, this stuff's dirty. The rest of it could be dirty. You get to the bottom and you go, okay, now I'm going to ask. And you go back up and you go up the tree and you go, okay, all the way till something's dirty. And then you start working your way down. And the benefit of this is if something later comes across and gets to a certain point and sees that thing's dirty, it doesn't have to go any further up. It only has to go up to the thing that's dirty that it needs to evaluate. And so you do kind of save doing the work twice. That fixes push. But on the other hand, because you only notified the things that could possibly be dirty, unlike React, you don't have to re-render everything, essentially, right? So it's kind of a bit of both. It's interesting that there's many more subscriber states here. I think someone actually sent let me see if I may want to pull Discord out off the main screen, but I think something was shared with on online. Let me see if I can. Let's see if we us on stream can make any sense of this. Yeah. What from the author himself? I actually was hoping to get Johnson on stream, but I couldn't get that to happen. But this beauty was shared with me. Yeah, I mean, looking at the amount of code, I imagine that the solution is incredibly elegant and direct, but hard to follow. Because I'm looking at this and I'm like, this is a system with 2 signals and 2 effects, if I understand. But I couldn't tell you for the life of me what's happening here. Kristen 720p. Can I blow this up a bit? Yeah, maybe this is a little bit better, but yeah, maybe we'll have to get Johnson on himself to actually explain what's going on here. I mean, obviously depth, subtail, depth tail. Yeah, I'm not even gonna take a guess at what this means, and which is probably unfortunate for a bunch of you who were looking for that expert thing. As I said, I called this the first look. I feel like I'm gonna have to get a little deeper to make sense of this, and not in the timeline that I'm looking at here. Okay. 5D scale drawing, like an alien spaceship. That's exactly why they made it this shape. It's like a UFO. See, it's like the bottom part of this thing, and they sit up here and look through this window. Yeah. Anyway. Okay. See, let's continue here for a minute, okay? Because yeah, I'm looking here at propagate, and I recognize the high level stuff like should notify, if should notify, but yeah, branch depth. Yeah, there's some stuff, right? Start tracking, that's makes sense, and tracking. It's interesting because we've been using linked lists as our ownership tree for Solid 2.0, not for our depths. Like basically, I took Reactivity and then added linked lists for ownership. So like some of the code has similarities, but I think the depth part is very interesting because it's like unless you're like really following like the linked list thing, all the processes are just become a function of the linked list, right? You're like, okay, like instead of being like, oh, for something in array, you're now like going like, okay, what's going here? Get the depth, go there, next step. It's just kind of interesting. I'm not gonna lie. Obviously, I'm not gonna write out the algorithm here and figure out how it works at this point. I wanted to see high level what I was looking at, and high level, I think what's really clever here, because I'm almost at the end of the file. Yeah, I'm basically there is valid link. Yeah, clear tracking. Yeah, okay. Is all the code is linked list code. Like, I think what makes this solution so simple and elegant in a sense is that every single function is just a function of working on this one the set of linked lists, both the ownership graph and the dependencies and the subscribers, like both sides. So like everything just gets boiled down to linked list operations, which is probably really hard for the layman to follow, but on the other hand, means that like essentially there's no other code. It's just like the whole question is like, how do I put this data structure together? It's completely data structure driven, which is like incredibly cool and apparently incredibly fast. Yeah. Yeah. I mean, yeah, there's a lot of flags. Well, the thing is, Milo was talks to Johnson, I guess, a bit, and was like, it looks like got him to implement alien signals using slots like S.js. Just something these kind of guys do for fun. And see here's system TS with slots apparently. Maybe this will make more sense to us. Computed, effect, tracking, notified, recursion, dirty, pending. Okay. So how is this different if we use slots instead of linked lists? Okay, I mean, depth, length, add length, sub slots, depth slots. This is what I'm talking about. So yeah, keeping track. It's interesting. Oh, it's because you keep track of you can't because I guess because the array can be whole. You don't want to keep you keep reference to the length rather than like using the array's own length. But essentially, subs, depths, sub slots, depth slots. So like the double arrays on both sides. It's interesting to see that if the propagation could be done in the same sort of way. It's funny, the code's a little bit shorter there, not implemented. Okay, yeah. So this is just kind of like a concept, proof of concept. Very cool to see them playing with this. It shows a great understanding of the different reactivity systems in general. Um, Milo also sent along a benchmark. Let's see if maybe I can open this in a browser. Why am I not? Sorry, give me 2 seconds. Usually when I open stuff in Discord, it just says like open link. Bang. Okay, here we go. Oh, I mean, alien signals recursive calls with slots, and then solid 1.0, which is like obviously by comparison. But alien, yeah, it looks like the slots here are generally a bit are generally slower. Seeing here, I wonder if this is fully optimized for something just whipped up. That's interesting. Anyways, oh, apparently we have an updated one. Just a second. Open link. These guys are like working like 24/7. I don't even know what. Oh, okay. Yeah, this is different. Yeah, okay. Oh, with one placeholder slots. Okay, this performance is much better. Slots are slower than the current alien signal solution in most cases. Not all cases, though. I will point something out. I actually think in this benchmark, I don't know if you guys can see this, but create data signals like from here to almost the end. This is the S.js benchmark, and the S.js benchmark is broken in these libraries. I went to go test stuff with Solid 2.0, and I was like, wait, this isn't comparing to 1.0. And I'm like, wait, this is not actually working because S.js assumed everything was synchronous, and almost every single system isn't synchronous now. So it's like basically they're not measuring the thing. This benchmark was all about creation times. It's why I always felt it was the most representative of like real world rendering. And Solid's like off the charts here. It's because like literally Solid's work is being measured, and these guys are just like calling a function, and then the measurement ends before they do any of the work. Um, I talked to Milo about actually fixing this because it's my favorite reactivity benchmark, and it like actually doesn't work with any of the current libraries. It's kind of interesting how people reference this um, what do you call it, the JS reactivity benchmark all over the place, but there's actually like there are a few specifically with this one benchmark. There's actually like issues that make it not actually accurate. Anyways, sorry, let's get back to where we were. Yeah, I mean the thing is, there's this desire to. Yeah, I mean, I think this is. I mean, you're don't ruin my whole stream for me here, but I'm we're getting there. I have to build up the importance of yeah, exactly, which is making the benchmark kind of not make any sense. So yeah, I mean, it's definitely really interesting. Let's actually look at those benchmarks now, because as I mentioned before, Milo created the original benchmark and he posted it way back and he showed the results. And um originally it was like his tests, which you can see the scaling kind of go on there. And then when you get to you can see it right here. When you get to the tests for the SJS, everybody's like the same, except like there's yeah, like I don't know. Something's just not. Anyway, in let's the thing is, this is not the version of the benchmark that most people have seen now, because Alien Signals isn't in it. Someone cloned his repo and added uh Milo and added Alien Signals. And I think this is the one that everyone saw for a while, because this kicked up a bunch of things, because there's like Alien Signals and then Reactively, which Milo's library, and Svelte 5 right next to it. S.js still very fast 14 years later. OB, Mol, Preact Signals, USignal, Solids implementation, Signia, MobX, Vue Reactivity, TC39 Angular. Everyone giving them a hard time. My understanding is that the performance here has improved significantly, but and the benchmark's been updated. But this was the thing that got everyone's attention. They were like, "Wow, what is this Alien Signals thing edging out Reactively? We thought Reactively was the fastest, you know." Um, and it it is interesting that we're kind of getting to like this point where like we didn't actually think this sort of improvement was possible, honestly, for a while there. For those who don't know, Solid 2.0 is built on Reactively. It is slower than Reactively because we add a bunch of stuff. The same way that Solid SJS is Solid JS was built on SJS and is slower than SJS because of the extended capabilities of our reactive system. But Alien Signals being faster is interesting, because if you can improve the baseline performance, maybe that could actually impact other things. That's sort of the question, right? So yeah, I mean, I don't know. As I said, the benchmarks need a little bit of work. Milo has told me that he is working on it, so to speak. He's actually been. When we get Milo is always tricky, because he's in university. So part of the year he's very active. The other part of the year he's doing a lot of other stuff as well as his schoolwork. So it's tricky. I don't know if he's been working with companies, advising them on their reactive solutions. I think he's been working with like Google and the Angular team a bit too. So it's almost summertime, so I'm expecting we might see some movement coming here pretty quick. But anyway, back to Alien Signals. Impressions. I think it's very, very, very cool when performance can be improved in a marked way. As many of you know, though, I've been a little bit skeptical of the value of this performance improvement, right? I think, I think that the value is, if you can create an implementation that's fast in all different languages and it's straightforward to implement, so that everyone can just like copy this and post it, and it's small. I think that value, it outweighs the performance value. Just to have like this baseline, like, so I think that's more the interesting part. And it does, because I told you guys at the beginning of the stream, that's how I build. I start working on something, and if it isn't fast enough, it's not worth doing. We have to rethink it. We have to approach it a different way. I'm actually going to have an example of that a little bit later in the stream. I want to talk about deep tracking in stores, which is an interesting problem that I just solved this week. Since coming back, I it was actually Vue inspired. We're doing a lot of Vue stuff today. But before we get to that, I want to continue the discussion on alien signals. What I'm not clear about are the trade-offs. Well, I don't think there are many here as a base level. This is just smaller and faster. It seems there might be like some behavior differences people aren't accustomed to. Everything has this little thing, but at the baseline, I mean, Vue's betting on this. It seems like it's just an improvement in terms of internal algorithm piece. As I said, this is not where I've been, because I've been literally taking something and butchering the hell out of it to make it work with async, and then I'm gonna get to performance again, so to speak. Apparently, I completely killed Reactivity's performance with my async work. Not complete, but the funniest thing is, it didn't kill its performance. It killed its performance in the JS reactivity benchmark, but it didn't kill its performance in the JS framework benchmark. In fact, Solid 2.0 is faster in the JS framework benchmark, even though the reactivity was slower in the reactivity benchmark. So, which it's kind of I want to how much you trust the benchmark? This one, some of the tests are, it's a combination. If you, I mean, let's look at what's in this benchmark again, because there's basically, it's a combination of 5 different benchmarks. Sorry, I already had it open. I don't know if they're all in here, but the first set of benches up here at the top that Milo wrote, I trust, and they're pretty good. The Cellx ones are kind of a waste of time. They test depth. That they work. There's nothing functionally wrong with them, but they also are like almost completely useless from a like we don't see 5,000, 20. We rarely see 1,000 depth. That's like picking, having computers of computers of computers of computers of computers down 1,000 layers. Like, you're more likely to have maybe a depth of like 5. You might have like 1,000 of those. There's a few threads that might have, but you're not. Yeah, like, ownership will break this apart naturally. You're not, like, generally speaking, you're going to rerun subsections of things. You're not going to like basically chain. You have nested stuff, but you're not going to like chain a derivation tree for 1,000. So, as I said, this benchmark is always, this is the one that Preact guys like to always use, and it's almost useless. Like, if there was Cellx 100, that would be like a decent place, because then you'd be like, okay, this is an over exaggeration, and like, this is good to test, like, because you always exaggerate with benchmarks. You're always going to go over the top to try and like push the extremes, right? So that you can say, like, on this particular vector, how hard can we drive it? This is like 2 orders of magnitude past usefulness. This is like if someone took the JS framework benchmark and was like, let's put 1,000,000 rows in that table. Like, that's never happening, right? And then this the mall benchmark is interesting. I trust Ninja's work, so I think this one is probably relevant. This next set here, avoid propagation, is from Kairos, which used to be the fastest reactive system. This one is pretty good. And then the S.js one is my absolute favorite down here, except for the fact that it's basically broken with the current slew of libraries. So you can't really trust this one at all, which is almost half the test on the thing. So like, there's a mixture of like useful tests that are accurate, useless tests that are accurate, and then not accurate tests. So yeah, this one's a bit of this one's a bit of a mixed bag from my perspective. Well, that's the funniest thing. In when you run the Cellx benchmark in StackBlitz, you actually had to deal with the Stack Overflow. Depending on there's a bunch of libraries that can't run it because the way that they do their system uses recursion, and the stack gets too high, and StackBlitz actually Code Sandbox actually dies on the Cellx benchmark. Obviously, Cellx doesn't because they wrote theirs in a way that doesn't use recursive functions. So you can argue like that's a win for them, but it's also kind of like what I mean. There might be a problem space where you need that, but that's not within the realm of like anything that remotely matters in like typical application building. If I'm a part of the JS framework, actually hold meaning in real cases, geo section of the test are useful. Yeah, okay. Well, and this is what I'm going to get to because like, let's talk about if we're going to say like, okay, I think we can conclusively say through the suite of tests that alien signals is probably the fastest performant approach right now. I think this is a fair thing to say. I think that there's enough accuracy in enough of these tests that we can actually say like it's pretty sweet, you know. But what impact does that have outside of this micro benchmark, right? Let's go up the next level. So yeah, JS framework benchmark comes to mind, right? And it's funny because this question of what part of the benchmarks interesting or useful is a tricky one, because for those who are aware, there are several benchmarks on the performance side. There's one, two, I think there's 9 if I remember correctly, and I wish I could hide the ones that are quote unquote breaking the rules or cheating, because they basically just are native DOM. Like you can always do faster by just like updating the DOM with vanilla JS. Like you can always just like skip the declarative part of it. These ones should be gone. But like what you'll see generally speaking, performance wise, here is we got Svelte. Oh yeah, Svelte's ahead of Vue Vapor here. Solid's this run is behind them. Last time we were on stream, Solid was ahead of Svelte. Basically anything from about where Molina is here at 109 to about, I want to say, Wasm Bindgen. More Sinuous. I'll say Sinuous here. Well, I could even count Vue, RX, JSX. Anything in this zone up here, basically, there's enough variance in the test that their positions can swap thing to thing. The value here is when you look at the specific things where you're like, okay, Solid's faster at select row, but has this performance overhead that the others up here, you can see it's on releasing on clear rows. In fact, this is one of the biggest, this is the improvement we made in 2.0 by using Reactivity. We solved the performance overhead of releasing. Solid has one of the worst cleanup performances out of any of the frameworks that are in the top lit, basically until we hit even lit, yeah, in the top like 20 or 30 frameworks. Solid has, this is like one of our weakest points. Of course, any one of these single factors on a single test, because the weighted geometric means, basically moves the number like 0.01. So that kind of difference ends up making less of difference in the variance of the tests themselves. So let's getting back to what these tests are valued for. Create rows, obviously, create a bunch of rows. So it's a creation operation. There should be at least one. There's also create many rows, 10,000 rows. These things are similar but slightly different. There is the obviously like raw creation code timing, which adding nodes, bindings, all that, but it's also a memory overhead consideration. Mostly this is where you will feel memory pressure, especially when you get to 10,000, and especially with this other one where we append. Appending is not a expensive diff operation, because you can literally but it's still, you have a big list and you add a list to it. It does test the diffing and the creation a bit. So these are distinct cases. And small versus large create many does have different memory pressure. So I think it's worth testing both of those. Replace rows, again, this is testing both the creation and the removal at the same time. Fairly typical operation. I think it's a reasonable one. A lot of these tests are creation based. That's why I was saying the S.js test was most indicative of this. Okay, partial update. This one is an important category because this is like when you have a granular change, like you're updating the text in one row or multiple rows. This is your typical fine grain test because you have multiple different data sources that are propagated through your data. So if you have like everybody has a name and you add an exclamation mark to the end of the name, on every 10th row or whatever, that's what this does, every 10th row, then it's going to update in those 10 distinct places. Like if you're in a signals library and you have nested signals or stores, or, kind of thing, or reactive in view or whatever the hell you call it, you could possibly just update those single spots without re-rendering the list. If you're React, as you know, you re-render the whole list and then you diff it and then you decide it. So there's a conceptual difference here. Don't get me wrong, React's pretty fast at that. Do you know what's a fun little side note here? Look where Inferno is right here. I was talking about Vue Vapor and Svelte. Inferno, which has not been changed in like 5 years, was farther back in the past, but browser is this run up here. To be fair, Inferno is in the same category of performance as the rest of these, because not from its doing, but because the way the browser has changed over time. Inferno's actually got better in performance. Interesting. Anyways, but we're at a point now where this whole front of the list is basically interchangeable. Especially, as I said, like even up to, I'd say, like MobX, JSX, like this range up to 1.1. The first, if you ignore basically the first 0.05 that are basically all cheating, you'll see Mikado here, which is marked as not cheating, or like, but they are actually kind of cheating. This is contentious, but the Molina today is the fastest as far as I'm concerned. But basically, this range of from 1.09 up to about 1.15 is basically interchangeable at this point. And we've kind of hit a wall, and we hit that wall a long time ago. We hit that wall 7 years ago. Yeah, it takes one to know one. Okay, do you want to know? Do you want to know what he's referring to? Let's see if I can. Sorry, let me change how I share my screen. Give me 2 seconds. I think this is worth calling out here. Let's present. Give me 2 seconds. And actually, I want to get the actual share screen Chrome tab. I want to get the whole JS World talk, not just my clip. Sorry, give me 2 seconds. Let's see. I think this is worth, if we're going to talk about the JS framework benchmark, we should talk about this on stream, I think. Give me a second. I've been kind of away for a month, so I'm sorry if this comes like the thread is stale, so to speak. But I shared this on Twitter when I saw it. But let me see. Someone, I think it was Burke, shared this with me. All right. Right. Okay. Beautiful. Okay. Let me share. Sorry, if I want to share audio, I need to share my screen this way. So give me 2 seconds. Okay. You guys ready? Yeah, honestly, if people like sub, the whole game, it helps the stream a ton. Um, yeah. Sorry. So there's a mention here that Wasm bindgen is not a reactive library. Yeah, it's basically vanilla JS for Rust. So technically, sorry, that one is it'll have 772 next to it. It's like cheating because it's not cheating. It just means that it's not actually testing the thing the test checks. And yes, we're gonna get there in a minute. This is where I'm getting to. So yeah, let's watch this.
A final release in 3.6. And the nice thing is,
can you hear this? Like, was the audio working?
we're actually not doing any benchmark-specific optimizations. For example, Solid.js is really, really fast in this select role benchmark here. And you can see both Vapor and Svelte is relatively slow in this one. This is actually because vanilla.js uses imperative DOM manipulation. So when you select a single item in a really, really long list, it's just one line of code. But when you write declarative templates, we still have to loop through the whole thing to figure out which one is selected. Solid actually kind of cheats a little bit by using something called create selector.
He said
that's
a little bit
optimization that's basically specifically just for optimizing this specific entry in the benchmark. We can do something similar, but we choose not to because we still beat Solid in this case without even doing it. And another important thing, like I said, is virtual DOM Vapor.
Because we beat Solid without doing it. But this is people. I cut that last bit off on the Twitter thread because I wanted to be nice. But that's the same mentality that is propagating the problem, right? Like, because like the results are the same. Like, if you look at the when he ran it locally on his computer, Solid's faster than Svelte on this run, and Vue Vapor's up front. As we know today, Svelte is faster than Vue Vapor. It's not because Svelte has changed. It's literally run dependent. No one is particularly faster. We have two libraries that have slightly slower select rows versus one slightly slower than this. And even when you add Solid 2.0 out, which fixes this, it's still within the variation. We're talking about libraries shaving point like 2 or 0.3 or maybe 0.5 of a millisecond off a specific slowed down JS operation. In fact, Evan knows this, right? Because I made some call about, been cheating for 7 years. I guess I took to Solid. Like, I did this 7 years ago when I created Solid, right? Like this implementation. And do you know where I got Create Selector from? I was working. Sorry, I'm going to change how I'm sharing my screen. I was working at a startup that built imaging, an image, kind of like an Instagram / Google Photos for schools, and we had giant, image grids, infinite scrolling, multi-select, drag and drop, and they weren't just square like simple let CSS do, and they used a justified grid scroll. So like the images actually fit width based on the height, and like we also did some stuff that was like Pinterest style where we did the masonry grid. So we did a lot of like grid layouts with multi-select and with drag and drop, and the selection context could also be injected because different permission sets, different capabilities on different pages on those grids. So like you had all these different like some triggered modals and different workflows, wizards, like all these different processes around managing large grids of images. So it was that real world experience where Create Selector came from. So it was like kind of obvious to me that this was a problem that I need to solve. Like, selection is getting back to the JS framework benchmark, is a different category than partial update, because partial update you have data in each row. Selection's interesting because the data isn't owned for the row. Now, some people, and I don't know if this is marked as cheating on here, it might be, it's like 801 or something. It's possible to put the selected data on, like say is selected on each row. that is faster than just having a single selected. Like if anyone's seen the code for the JS framework benchmark, let's pull that up just so you can get an idea here. Is let's just pick, it doesn't really matter what implementation I pull up. I could just pull up solid because or React hooks, sure. Let's look at React hooks. React hooks is fine. Most people know React. The point is, partial update is built based on, where's it, main jump button, a row. Because essentially you have an item label and you update it. So every row has its own label and you update that label, right? Whereas selection is based on, am I selected, show this class versus the other class. So the idea here is that essentially there's a single selected state that gets projected onto the rest of the data structure. So you basically have to like, I don't know what the term is. There's probably a better comp sci term. This is not what a projection is. Someone told me, but this idea that you basically have a single source and you actually have to spread it out onto the rest of the data structure. And there are many problems in UI and in software that resemble this shape or pattern. So much so that in Solid 2.0, we have a primitive specifically for this. Like Trait Selector is like a slightly narrower version, I admit. But this was so important to me that we actually are shipping this as a baseline because it's a whole category of reactivity. And I've done 2 streams actually on this topic specifically, I think at this point. It's not this here. Let me get back about the whole idea of mutable derivations and whatever. And one stream to explain the idea, another stream to show how we've effectively implemented it. But this is a category, just on a side, that I don't think people should sleep on. So anyways, just we see this every day, like when you have indexes being pushed onto an array, or I have a bunch of examples in this article, but the core of it is essentially is if you have this kind of grid and signals are kind of immutable and derived signals computed are kind of immutable. You basically give a function, you put input in, you get function out. It's kind of pure functions approach. But stores with their nesting aren't immutable anymore because you can change things lower down without notifying the thing above. And I was like, why isn't there a mutable derived primitive? I think projections, even if not as commonly used, are as core as, say, refs if you're in Vue, and reactive if you're in Vue, and computeds, or if you're, these concepts are in all the reactive libraries now. They just don't implement this. So yeah, I mean, I was a little tongue in cheek here. I'm like, if it took them 7 years to realize that, Solid was cheating, how many years is it going to take for them to realize that their view of reactivity, is missing part of the picture? But it's fine. I'm not gonna stress too much about this. I just what I'm getting at is like there is more to reactivity than what we've done to now. We're like at the beginning of this journey. It's so exciting to have so many people along with us. So we have different people working on different parts of the problem, and something like alien signals being able to work on like really refining the performance on optimizing the very baseline core is absolutely amazing and absolutely needed, because honestly, as I said, a lot of my stuff's a mess. Linked signal is the left side sync headers and memo. Yes, it is. Yes. They call them linked signals. In Solid, we literally just added a function thing to the thing. This is something that, yeah, we talk about it in that article, the linked signal concept. It's something that I kind of first proposed about 3 or 4 years ago. It just took me so long to get it out. But I think, yes, they're writable memos, but technically speaking, they're still atomic. Like they're still like they're still immutable data structures. Like they're in the sense that like signals are. We're at the beginning of the best friends. Yeah, thank you. I mean, I've been trying to set those milestones. If you've been watching my streams, I think the work around both mutable reactivity and async are in their infancy, and I think there's a lot more to go. As I said, I'm very excited about it. Right. I think there's. I mean, we did this part of the conversation. The API isn't really relevant because people are going to wrap stuff anyways, right? There's this alien signals use the dot value thing. That's the only thing I can say. The frameworks that use dot value are just actually wrong, straight up. It's fine, but they are. It's just yeah. I mean, people are not going to agree on the API shape. There is a mechanical reason why dot value. There's a performance reason why dot value is right, and a TypeScript reason that's arguable. But the TypeScript reason is incidental. The mechanical thing is fair because dot value lets you use the prototype, so like it's can be more performant. But from a composition API standpoint, functions are superior. Or like what Svelte does, where there's no function and it's just a variable. Like technically, but the problem with that is obviously that they're just hiding that there's functions. So the second you transport it, you need functions. So then, I'm sorry, like you're not actually saving anyone anything. So like it boils always down to functions, and functions are the key composable piece. The fact that you can literally just go function, call function, call function is something that you can do in all of these frameworks. So it is the most primitive thing. Dot value or whatever turns the shape into something special, which it shouldn't. Oh, they do the knockout thing. Maybe with TypeScript this is fine. This was like the worst in the knockout ages. I'm not gonna like because without TypeScript, people would accidentally pass setter functions or getter functions into other functions, and then they get called with an argument incidentally, and then just set the thing and screw the whole thing up. This was like literally I ran away like this, like I was I told you that big app with create selector which we wrote it. It was written in Knockout, not in Solid or React or anything. I had tons of experience like that. And to be fair, don't get me wrong. The reason that app probably needed create selector and had that performance overhead is because we were using web components, right? In my infinite wisdom at the time, I thought we don't need real components. We don't need component model. We can use web components. We can use reactivity. This is going to be great. And then we just blew it up, added web component, and now suddenly all our updates and props and our attributes are running through DOM life cycles. So like you better believe I had to optimize something. What I chose to do was optimize our ability to propagate this change through the system, hence create selector. So another thing that we can thank the web components community and web components for in general. They've definitely innovated me in the past to build things that are more performant. Calling out the way they intended, obviously. I mean, they're the same. As I said, web components also the reason I created a framework. I was like, oh, stuff's built on the platform. It should be really easy to create a JavaScript framework. Or like, I wasn't even trying to create a framework, if so to speak. I'm just trying to build something. So, I mean, web components are great. They definitely let you learn how to put you in a position where you get to learn how to make things more performantly. Yeah, yeah, that was a very long time ago. Were you even around, or you just remember me telling you about that at that point? Yeah, I mean, Knockout's great. The funniest thing is, I mean, I don't know, like the reason we were getting here is because we were looking at the JS framework benchmark, and the reason we're looking at the JS framework benchmark is I wanted to actually show everyone something here that they may or may not be aware of. While we were sitting here looking over the performance pieces of this, and you're going to see that, and I think regulars to my stream are aware of this already. You're going to see that up at the top in this range of things that is basically interchangeable with each other there is Vue Rx JSX, Knockout JSX, MobX JSX. What are these libraries here? And do you know what these libraries are? These are libraries that I wrote using the varying reactive system, using DOM expressions, using the exact same uh, essentially renderer that Solid uses. I made one for Preact too. I just didn't publish it at that time. So this whole 5 years now, under the radar, this Vue Rx JSX has been sitting here right at the top. Do you know what this is? Basically, I created Vue Vapor 5 years ago. It's just been sitting here, and don't get me wrong, Vue Vapor is faster apparently. So I mean, you can see it is actually faster. The biggest difference between DOM expressions and Vue Vapor, I imagine, is that DOM expressions API shape was built with Solid in mind, so the wrapper is less optimized slightly to fit the shape of what Solid's API is versus Vue's API. But as I wrote this in over a weekend kind of approach, and I was always impressed with Vue because Vue's faster than Knockout. This is so funny because if you use actual Knockout, it's like back here beside Quick or Alpine, or where is it? Knockout, yeah, right here. Ember, all the grades. But if you remove the renderer and just use the reactivity, Knockout, is pretty swell. Where is it? It's right here. So this is Vue. See, look, Vue.jsx Vapor is actually still behind the DOM expressions JSX. So maybe our JSX compiler is slightly more optimal, but it's probably just the same thing. It's like 0.2 apart. It's within variance, probably. Yeah, I wrote the Preact one in stream. So I was thinking, I was like, could we just update this to alien signals and see if it makes any difference? Like, would that be something fun to do? Like, because would that? I mean, I guess this isn't even alien signals version of Vue Vapor. Like, I wonder if that would cause some big movement on this chart. I mean, that was something I was thinking about. Because you got then again, I was looking at this and thinking about how old is this anyways? I wrote. Do you want to know when I wrote this and why I wrote this? I mean, it's petty now, but in a sense, but I worked really hard early days with Solid trying to promote the idea. Now it's funny that we have Svelte 5 and we have Vue Vapor, which are basically very, very similar in concept. But when I talked to the developers like Rich and Evan back in 2020, they basically told me that that's interesting, but there's a reason we do things the way we do those things, right? And I mean, I get it. It's fair, but I was reading an old article I wrote and I came across this the other day. Sorry, not this. Where is it? Not the selector. Sorry, this is different. What's this? Sorry, give me 2 seconds. No, this is not what I was looking for. These solutions, yeah, no. Yeah, this is him just saying that he's agreeing that the create selector is not benchmark specific. Okay, yeah, this isn't what I was looking for. Sorry, give me 2 seconds. All right, this is what I'm looking for. Back in May 2020, when Vue 3 was released, I asked Evan, I'm like, I'm unclear why you stayed using a virtual DOM after those changes. You alleviate a lot of the need for it once you break things down that way. Sure, diffing, there's a virtual data representation of sorts, but hardly need to do a full down, top down path, even if you skip parts. Basically, when Vue released Vue 3, they had an opportunity to make a change because they were making already a huge change with the composition API. And Evan's answer at the time was because Vue allows you to write manual render functions and mix them with template-based functions, giving up VDOM is giving up an important capability for advanced use cases where logic expression is more important than a bit of performance. I wonder if that's still the perspective now. It would be curious to know, because yeah, I did not have very much success. It's kind of funny. Again, I don't know if Solid would have ever gone to 1.1 if Rich or Evan had actually, been like, oh, this is really cool, we should do that, But I mean, I don't know what I was expecting either. So I mean, I'm glad to be here regardless. But it's been a very kind of interesting experience, kind of watching this progression of the frameworks kind of slide into this zone. I mean, yeah, I don't know. It's kind of funny. Knockout now is getting kind of heralded like 15 years later as like the thing, there's like, yeah, Knockout was doing this 15 years ago, why did we all lose our way? And it's but like, try and find someone talking about Knockout back in 2018 or 17 or 19 or 20 or 21. Everyone these days is very quick to say like, oh yeah, Knockout was right all along. But like, there was like 7 years in the middle between like 2014 and 2021 where literally no one referenced Knockout. Yeah. Five years ago, no one used Signals and no one knew about Solid. Now everyone uses Signal, no one knows about Solid. Oh, well, I at least we reached the right people. The people that were able to actually implement the signals in their respective libraries. Yeah, React was sucking up all the air in the room at the time. But even in the alternative space, like when Svelte was released in 2016 or Vue in 2015, they could have been like Knockout, but they didn't. When hooks were released in 2018 and React were like, look, we can use primitives, they could have chosen to be like Knockout, but they didn't. Right? They that's when like they're like, oh yeah, we can use like Vue. Svelte 3 came about, and Vue was like started thinking about the composition API. In 2020, when I reached out to both Evan and Rich on Twitter, they could have looked at Knockout, but they didn't. But in 2025, everybody's Knockout. So, yeah. Yeah, I mean, it depends on where you're sitting. Like, Knockout was not as popular as jQuery, but the funny thing that can gap by is there was a whole period between jQuery and React, ironically, 7 years, which is the Solid. On my birthday this year, I had an amazing birthday gift that it'd been as long from when I open source Solid from the difference between jQuery and React. But there were other solutions at the time that were actually, how should I put it? Doing the declarative stuff. Knockout was one of them. Knockout came out before Angular or Backbone. It just wasn't as popular. But it was still a thing, right? I mean, my Create Selector story was from 2018 ish. I was working on Knockout in production for 9 years. I used Knockout at one company from 2012 to 2019-ish, 2020-ish. Actually, they were still like on 2020 in production while we were doing the React rewrite. And then I'd used React Knockout for about 6 months at my previous company. Anyway, I don't know. I mean, we got some topics to cover. I mean, we could go in and we could set up the JS framework benchmark definitely, and see if alien signals does the thing. I mean, I think we have everything we need. I think the most interesting thing is that alien signals has effect scope, which means if you've ever seen my Vue RX JSX implementation, I actually have to invent ownership scope to inject it into it. And to be fair, now Vue probably has ownership scope. So the problem is maybe too much has changed that it won't be comparable anymore. Because like the problem is when I wrote this, Vue didn't have ownership scope. So I like untrack, pause tracking, reset tracking. I actually had to create ownership scope, create my own global context, and then make effects and memos that actually re-injected the ownership scope. And basically, with all this extra cruff, that implementation with Vue was still basically right at the front of the list. So, and with Vue's old reactivity system, like before alien signals, before they even updated the performance, before they did basically anything. So I don't know. I'm tempted to do it because I was on the JS framework benchmark the other day, and there was an issue open here. It goes add alien signals to the test. Yeah, I mean, there's a want here, right? We can definitely do this. Yeah, I mean, we can basically, if alien signals already does self-releasing, we could probably just clean up this whole implementation. Maybe this is worth hacking on. Sorry, not solid suspense demo. Let me see if I have it locally. If I haven't installed JS Framework Benchmark locally, this might actually be a pain to set up for the first time, unless that's like what people care about to see on stream. And it doesn't look like it. Do you remember my computer got what? Let me double check. I ended up talking more about some stuff than I was planning to. Let me look at development. Do we have JS framework benchmarks? Signals solid. No, this looks like a brand new computer that doesn't have anything on it. Why? They have vanilla JS signals with TC39. Sorry, is that in here? All right. Well, I mean, I can start git cloning stuff down. Let's see here. Why is this URL? It's so funny that this is the URL in the. All right. What do we want? We want not JS framework benchmarks, of course. Okay, we want JS framework benchmark. We want. What else do we want? I did update it in January, which isn't bad. We want. Sorry, it's so funny. Clone. We want Vue RX JSX. See, look, I still have access to the repos from that startup that I was talking about. Not solid. Vue RX JSX. All right. It's in keyed. Okay. Let me. Oh yeah, Vanilla.js signals. Yeah, but it's a 7.7.2 implementation. But I mean, this is one of those things that I love seeing is like when you add something like signals, you make your app slower. It's science. It's only if you can remove the overhead of something else that it makes sense. So obviously, if your baseline is Vanilla.js and you add signals to it, it's going to be slower than just Vanilla.js. If you have React, you add signals to it, it's going to be slower than just React unless you change how React renders. If you add signals to Preact, it's going to be slower than Preact unless you change how Preact renders. And in the case of this benchmark, since it only impacts Preact's ability to render in like one or two places, it actually net is slower than Preact classes. So like the thing is, it's always kind of hard to tell, but like there's a different scale of optimization. Like, do we think like if you look at Vue here at 1.27, and then you look at Vue Vapor over here at 1.10, 0.17 improvement, like 17%, say, performance improvement. Do we expect alien signals to make as big of a difference as jumping from normal Vue to Vue Vapor? No, we don't. The question is, can making your reactive system double, triple, 3 times faster have any impact on something that's render constrained? Where's backbone plus signals? Yeah, that's what we need. All right. Okay, so let's see if we can do this. I guess the first thing is file open. Let's get out of here and look at. Let's see if we can get the JS framework benchmark running on just like a couple little things. This is always fun to do occasionally because we'll worry about ZSH later. Okay. This is always kind of fun thing to do because honestly, getting this set up for the first time for a lot of people is actually kind of a pain because I have to make sure that I don't run the wrong command because when you npm install, it ends up like it might install like everything. Let's see if this is what we want. Let's hope it doesn't install every framework. Did it actually work, or like, is it actually that fast? Okay, that's fine. And then we want to go into WebDriver TS and npm install in here too. And then WebDriver TS results. Let's npm install in here too. Yeah, I mean this is not. I think in all I'm going to need like 3 windows here. I'm going to need the main one that runs the server. So if I go npm start, this should start up the server on 8080. I'm going to need to go into a couple of the frameworks and build them. For the purposes of our test, we probably want to pick a Vanilla.js framework. So we'll go keyed, not broken, frameworks, keyed, vanilla. What's the fastest Vanilla.js implementation right now? Vanilla.js Lite. Looks sweet. Vanilla.js 3 is pretty close too. Any characteristics that are different? Yeah, okay, we'll do Lite. Vanilla.js Lite. npm run build prod. I don't know if Vanilla needs it. Okay. What else should we need? We need probably Vue. View. Sorry, what am I doing? Okay. We need Vue Rx JSX. We should definitely install this one. PM run build prod. Beautiful. We should have like a third point of reference for this to be worth doing. I mean, we don't need it. Let's see if we can get Vue Vapor. Yeah, let's use Vue Vapor as a third point of reference and npm install that. Okay. And now that we've built all our frameworks for now, we need one last window to actually run the tests. cd web driver ts npm run bench, I think. Okay, what are we missing? Okay, let's see if we can build here. It's a build. Compile is called. Is that it? Now can we bench? Okay, yeah. I mean, it's busted, but okay, that's fine. So then I can go like -- framework vanilla light. Is that, let's see, frameworks keyed vanilla JS light. What if they're gonna? They've changed some of the stuff over time. So what do we want? Vue Rx JSX and Vue Vapor. Okay, yeah, it did not match any of those. So I think what I actually have to do is put keyed in front of each one. Keyed. Sweet. Okay. Okay, so we had the benchmark working. I don't know if we want to run the whole bench suite right now. I think let's worry about that later. If we need to, we'll worry about that later. I just wanted to see that we have this working. Okay. So then the next thing we need to do is see if we can make a new version of Vue RxJSX, basically, which, let me see. I'm wondering if I can just kind of go in here and just like swap out the code in the yeah. So we just swap out this dist folder with whatever we build in the repo, and we should be fine. Okay. Yeah, let's do it. Seems straightforward enough. I'll just like make a copy of the folder. It'll make our life easier. File. This is an old version of DOM expressions, but I think it'll serve for our purposes, because basically what we want to do is we want to replace Vue reactivity bigger than this with like, what do we call it? It's just alien. Is it just alien signals? What version is alien signals on? 1.0. we'll just assume that we can add it at 1.00. Okay, sorry. You can tell I haven't coded up on this stream because my text is way too small. I'm sorry, everyone. Let's just get this going. Or it's npm, all these old repos. npm run build, does it still work? Oh, it's because I used to, okay, this is good to know. It's because I copied the JSX types directly into the folder instead of using a manual build process. That's hilarious. This is like no one other than me had ever done anything here. It's looking for them in types folder. I mean, let me try one more time. Sometimes it works the second time. Okay. Okay. Is it not even in the source folder? No, it's in a top level types folder. That's funny. This is actually, and it's right here, right? Sorry, like I haven't been in here in like. Okay, so if I delete this now, it should definitely work. Sorry, I built this repo like 5 years ago and I haven't done. All right, ta-da. Okay, and it creates our dist. Okay, okay. So now we just need to update our code to actually run. Yeah, it needs keyed JS light. Yeah, sorry, I'm just catching up. I did get to it, I think, properly eventually, right? Yeah. Yeah. Okay. Cool. And then what else do we need here? We need. Oh, I think I just actually need the types folder to exist. Let's see if we can just swap out a bunch of stuff here because index is fine. This is what it's expecting, including create selector. I think that's a little bit cheeky, but let's do it. Okay, let's look at the core from lib. Okay, so lib is where we're going to do all our work. So we still need to untrack. So let's switch this from this to alien signals and see what we get. Okay. So they don't have reset tracking. What do they call it? This is a little bit of an API swap up here. Where's alien signals? Index. We have, what do we have? Pause tracking, resume tracking. So reset becomes resume. Resume tracking. Okay. Shallow ref becomes signal, I think. Stop becomes. What the hell is stop? They have like a global stop. I don't think we're going to need this logic. I'm okay with this because what we're going to do. Let me see here. Untrack we need. Root has a dispose function. So I just need to convert effect scope into effectively. Sorry, we don't need shallow ref. I need effect scope into this API. So I think we can literally just, and we need untrack. Yeah, okay. So we need, because const dispose will equal effect scope function, but not quite. Oh, how do I do this? Okay, it's fine. Worry about the disposal in a minute. Because like, I kind of want to do this, but I my gut is that I can't do that. I mean, if you've never seen Marco and Marco 6, this is their intention, but then they realized we kind of hit a point where we realized that runtime reactivity was valuable. Like they even have cross modular analysis where you could actually like they basically could know the reactive graph by analyzing cross file like where everything happens, and even with that we ended up back at a runtime approach. So yeah, I mean, I can picture a system like that. I'm just, yeah, I have skepticism. Okay, so then because of this, yeah. So effect, but yeah, and actually we need to untrack the function. I think is the key, right? We have to go untrack. I think the problem is effects. I have no way to get the dispose function into here. I know it won't get called right away, but I might have a hard time. It's okay. We're not going to release the root. Um, I don't. Oh, right. But we might need to release the root. Anyways, let's cross that road when we get to it. Because then we basically have to get the const return. Yeah, so we need to basically do something like this. Let ret this return ret. So already this is a lot simpler. Why am I just being? Oh, it's because it's down here. We don't need any of this ownership stuff, hopefully, because it will just work. Shut up, TypeScript. I'm hoping effect scope runs synchronously. I guess we'll find out. I wonder how cleanup's going to work. Huh. Yeah, it's interesting because there is slight differences with the view ownership model. I might be better served to just leave what we're referring to as the garbage in, because then it's apples to apples with the current view thing. Because I'm looking at this and I'm realizing that like, how do you register? There's no mechanism to register your own cleanups, right? Like they have effect scope, which is great because I'm gathering it. I'm gathering this gathers up the nested effects, but how do I don't think I can arbitrarily attach my own stuff to it. I might not actually need it for this though, because we're just trying to do the benchmark. Right? Because let's give this a shot. We're just gonna have this be a no op for now. But I don't think there's a way to register your own stuff on their ownership graph. Yeah, and then the scope cleans it out, but there's no. It's the auto registrations there like us, but they don't have manual registration as well. I'm just gonna no op it and hope that we don't need manual cleanup for what we're doing. Similarly, I think we can just. What's their does their effect, is their effect function is probably not recursive. It's fine. I can write that in fairly straightforward. Effect function. Yeah, there's no previous values or concepts of that. That's fine. We can do this. So we still need it as v effect. Okay. We can remove the context API because we don't care. We can remove the manual cleanup. We just need to, I'm just going to call this value. And then what we're going to do essentially is now we won't need the cleanup because it'll be inside an effect scope. See, the reason we had, yeah, this is like really, I did some pretty heavy hacking around this stuff, eh? All we have to do is do this basically. So I call it current, but this should be enough. Much simpler wrapper. Yeah, okay, beautiful. Memo. I used a shallow ref and with an effect. Oh, wow. It's because of the way Vue used to do the computeds. That's funny. Okay, so I think we can just do this with do they are there computeds recursive? Yes, their computeds are recursive. Good. Okay. That makes life a little bit easier. Although there's no way to set the initial value, is there? No. Okay. That's fine. I actually don't need the initial value here. So we can make this, was it computed? Do they use equality? Is there a way to say like don't or do equality check in here? Um, I mean, I guess we can look at the implementation to understand if the computeds do equality checks. Sorry, what was it? What was the underlying thing again? Computed getter, which is, where is it? Computed getter. Right, but it's a computed. Okay, so it's this, which is the, okay. Let's look at the computed. Is there, what's the computed type actually? I mean, oh, actually, the update function is what they inject, isn't it? It's what we saw here. Yeah, it's literally right here. So they do equality check by default. That's fine. I don't think there's any downside to that. We're just going to ignore that. So we're going to assume a quality check by default. For the JS framework benchmark, we're not going to get an issue. So I think we can actually literally just go computed function, which means that this whole memo thing actually goes away. We can actually just export computed as, yeah, I like that. It's funny. I implemented like a bunch of other helpers like lazy and stuff. I don't even know if I want to. We don't need this for the benchmark, so I'm not going to put it in here. Context API. Don't need it for the benchmark. Tempted to get rid of. All right, sorry. So no actual. Okay, we need map. We don't need create provider. We don't need resolve children then. This makes life a lot easier, getting rid of all the extra stuff that we don't actually need. I don't even think we need split props because we need merge, but we don't need split. Yeah, whatever. It's not broken, so I don't actually care. What's this one? Create selector. Okay, I'm gonna have to rewrite the logic for create selector. I'm not too worried about that though. We don't need global context. It's gone now. We don't need context. It's gone. And then all we need here, export, was it computed as memo from alien signals. We don't need stop. We don't need computed. And then the last little bit of editing we have to do here is, yeah, this old version of Selector was a real masterpiece. Okay, so let's change this to signal. And then what's the type of signal? Okay, let's just any this for now. And then we just have to make sure that we actually set the signal properly here. Because L.value, that's a read. So this should be just call the function as the thing. And then increment the counter. Where's the right? It should be up here. Right. It's the only dot. There's no more dot values anywhere, right? Dot value. Okay. And just we know for sure, right, that it's they don't use dot value, right? Just sanity check. It's the knockout API. Yeah. Yeah, they don't use dot value. Okay. Yeah. Okay. Beautiful. Okay. Okay. So then, other than this not building, because I'm just going to be missing some exports that I'll trim in a second, I think this is it. Okay. Lib, and then index is missing context. That's fine. We don't need it. Lazy, create context, use context, all also not needed. Cleanup's a no op, but let's see if I can build. Looks good. Let's look at the dist. Okay, one thing I have to do is make sure that rollup is excluding stuff we want to exclude from here, like alien signals. Alien signals. If you didn't notice, this also creates a hyperscript renderer and a lit style renderer. But let's try running this again. Now, if this all works, we should mostly have just our user code. Okay, beautiful. and then whatever version of DOM expressions this is. Okay, that looks. Isn't rolled down in Elfo now? Yeah, I haven't been keeping up on it. Sorry, this is a little bit deeper than some people might have wanted to go, but I think we're good. So all we need to do now is go into JS Framework Benchmark. I'm going to do this really cheesy way, which is just copy this folder because we want to run both of them. And we have to just change a couple things here. Rename to view. Let's call it view alien JSX. And then it's not even view anymore, actually, isn't it? It's just, if I change the name right now, it's going to lose the alphabetical sorting order, and I don't want to deal with that. Let's call it, I'm just going to call it alien JSX. And then we have to change this to alien signals. Whatever version it's at, 1.013, if I saw it correctly. Yeah. And then we'll reinstall our, we actually don't need to that's fine, whatever. Alien JSX. And actually, sorry, there's a few places where we should change it. Alien JSX keyed. I'm not seeing it. It should be in the, yeah, alien JSX keyed. And then I'm going to npm install this one more time to get alien signals in here. And then I'm going to replace the view rxJSX code with the code that we haven't published yet. So I'll just replace this dist with this dist. Copy, paste. And if all goes well, we will be able to npm run build prod. All right. And then when I go into here and go to localhost 8080 and choose a framework, not found package lucky. Should fix that. Sorry. Let's do this. Oh, right. Yeah, I'm trying to think of how they have different keys here. I think this is not something I want to fiddle with. It's just like the worst name. Okay, what do you know? It doesn't even work yet anyways. Let's see what the console error. All right, let's not build prod. Let's see what we have done wrong here. Just build it dev. Oh, I probably don't even have a dev build on here. Yeah, no, I don't. Where is it? Wrong folder. Oh, just dev. All right. Yeah, it's what we thought it was. Can access dispose before initialization. Oh, lovely. Okay. Okay. Let's see if we can solve this. It's exactly what I knew the problem was going to be. It was the it was sorry, lib. It was this problem up here when I tried to make the root. Okay. It might be just as simple as effect scope returns a function that's void. If as long as we wrap it with a function, I expect this will work because no one's going to be accessing it synchronously. So let's try that. Paste. All right. Okay. Not working yet, but it's not crashing. Okay, so let's see if there's something wrong in the actual implementation that I forgot to update. Yeah, here's our problem right here. We need alien signals signal, otherwise we're not actually going to be able to do anything here. And then where did we call ref? Signal, and then selected data. Oh, do you know what? Yeah, we actually have to change this. This might actually be using the fact that Vue does deep, like stores. This actually might be because if you look at it, the label is not a separate signal, which means that in order to actually do this properly, we have to make this more. Yeah. Okay, I see what's wrong. This requires a few other updates. Okay, it's selected. It's selected. I just want to make sure everything else is fine. It's selected. It's selected. Okay. Yeah. Okay. So all these helper functions need to be changed. Data. Oh, sorry. It's funny. I wonder if I had started with the knockout implementation, I would have been in better shape. Because of all of these, like, yeah, like what did I do here? Da, 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 da. See, like this here is already a problem. It's got to be more like because each label needs to be a signal as well, which is missing. It's because Vue has automatic deep, which I don't think Alien Signals does not have any concept of deep reactivity, which is good because this will actually be more performant. Because the Vue RX version was actually using proxies. So I'm actually expecting. Yeah, this isn't apples to apples anymore. I'm expecting this to actually jump about 0.03, even without alien signals, purely from this reimplementation here. I wonder if I had used shallow ref, that would have been a better comparison point. Yeah, the proxies are always going to be slower, so I'm not gonna. Okay, so let's see if we've killed dot value. No, there's still more. Is that the last dot value? Okay, we've killed dot value. Can we create 1,000 rows yet? Yes, we can. Can we select a row? But the selector is not working properly. Okay, that's fine. Can we clear 1,000 rows? Yes, we can. Okay. Can we swap rows? Yes, we can. Okay. Okay, so stuff's coming along. My guess is we won't be able to update every 10th row though. Yeah, okay. So we have to create the nested signals. Okay, that's easy enough to do. Here, this should just be signal there. And then the label. Yeah, I need to actually change the Vue one to be the same if we want to actually compare this apples to apples, to be fair. So the only thing else we need to change is going to be the row rendering. We need to make sure that the row, where's the row component wrap? Row, yeah. The row component needs to make sure that the label is a signal. I think that's it. Create 1,000 rows. Update every 10th. Row label is not a function. Okay. What did I do wrong? Why is row.label not a function? Row label is a function. Right? Signal is a function, right? It is a function. Label. Oh, it's probably because I missed reading from it right here. Create 1,000 rows. Well, let's see what it is. What is it? Label is a function. Okay. All right. Looks like label is a function. Let's continue. When does label stop becoming a function? When it becomes a string. Okay. Yeah. So didn't I just fix this? It was what I thought. It's because I didn't call it as a function here, but okay. Oh, plus. Okay, sorry. The plus equals was the problem. All right, create 1,000, update every 10th row. Yay, okay. All right, progress. Okay, so we can swap, we can clear, we can create 10,000, we can append. Okay, so we have the makings of a thing. The only unfortunate part about this example is that the original Vuex JSX version is not comparable. So what we're going to do is the only difference is replacing shallow ref with signal here. We're going to actually just copy the code into our other repo, or sorry, other one. And now this way, Vuex JSX is actually comparable. I probably went with store type APIs because like as a like I thought it was kind of like the expectation, shallow ref. Like as a Vue user, I also I don't think knew about shallow ref. Oh right, but the shallow refs, the shallow refs are gonna have dot value on them, aren't they? Oh right, okay, it's fine. Yeah, actually, I'm gonna undo my changes because it will be still easier to just change this to shallow ref and add the one extra thing than it is to go through and do the rest of this crap. Ref. Okay. Shallow ref. And then we want to add label is shallow ref. And then the only one that we're going to have to change now is the update part, because it will now have to be dot value. And then inside the render, where we look at the row here, where is it? Row list. We have to go dot value because our JSX is not like Vue has some stuff where like it. Okay. Build prod and then cd dot view rx JSX build prod. Okay. And now if everything is good, this one works for everything. Oh no, do you know what? I forgot the test selection. Yeah, selection's broken. Damn it. It's fine. We'll get that in a second. Let's see if Vuex JSX works. Vuex JSX. Create 1,000. Update every 10th. Yeah. Swap rows. Selection working properly. Yeah. Okay. So yeah, we just need to fix the selector and then we'll be done for the other one. Okay. Sweet. Okay. Yeah, I did not know that either. That's we learn stuff on the stream, don't we? Okay, cool. So yeah, let's just fix the selector. This is probably just something that I did silly in here. So let's do that. Alien JSX cd dot view alien. There's actually nothing view about this, but that's fine. Actually, you know what? Let's just to get the stupid thing. Let's just say let's just do alien signals. We'll just call it alien signals, and then we'll have the version, and then whatever. It's kind of a lie, but it's purpose for our purposes demonstration standpoint. That's fine because this is okay. So then, what am I missing with selector? Selector selected. More than likely, the problem is actually something I didn't do right here. So I read the source of the V, and then I go through each one, and then I do a comparison, and then I set it, and then... Oh, do you know why Selector is not working? This is the one place that uses cleanup. Mm. Mm, 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 mm. Yes, that's why we can't do. That's why we can't use the selector here without, because the main reason I actually use on cleanup is for internal reference counting in React system. I use it for suspense. I use it for error boundaries. This is like basically the only real reason why your pure functions would clean up. But yeah, I mean, it literally can't clean up because I have no way of registering with the ownership graph. Okay, we can just not use create selector. Um, I also have a slower implementation of create selector, but I mean, I don't want to. It's possible that it's slower than just not using a selector at all, so I don't want to risk that for the sake of this thing. Okay, so what we're going to do is we're going to also remove create selector here, which is simply means that we just change this to selected equals row ID. And now create selector is gone. All right. See if this works. Done. Okay. Can you use the end tracking functions to subscribe to nothing and clean up? Yeah, I guess the question is, how do I trigger it, Milo? Like, look, let's look at this, because when you go is selected, you're running inside a reactive scope. It's not final cleanup. I just want that run to clean up. Like this cleanup runs every time it's re-rendered. It goes, okay, because it basically always counts up and counts down. It's just a counter. So every time it runs, it decrements and increments and decrements and increments, and then it's like when it's actually zero, it goes, okay, I'm going to delete it. That end tracking trick, I think, is for like final cleanup. It just means like when you put a stop on an effect, the effect never exists anymore. This is actually just part of the cycle. So yeah, I don't think this actually work. That will actually work. All right. In any case, we have all our working approaches. So we can go back here and actually run them all. We have, and what's the last one? Keyed view alien JSX. So let's run the benchmark while we chat. Actually, you know what? Do we care about memory benchmarks? We can cut our time significantly if we don't care about memory benchmarks. Let's not care about memory benchmarks. Stop. It's like, can I get in there fast enough? Okay, I think I did. It's got a mind of its own. Oh man. I swear I... All right. Oh, I see the problem. I didn't stop the right window. It's like... The problem is it steals the mouse focus. So even okay, sorry. Yeah. Okay. Yeah, I think that we actually want benchmark 01, 02, 03, 04, 05, 06, 07, 08, 09. We're not going to worry about memory right now. Let's do this. All right, cool. Okay, so we're going to let this run for a minute, but we can chat. I'm actually pretty excited. I got a couple more. It's been like a month since I did a stream, so I actually have a. Oh yeah, see, this is something sort of new on the JS framework benchmark. It actually, instead of running through all of them, it used to go like 1, 2, 3, 4, 9 for the first one, 1, 2, 3, 4, the second one, the next one. Now it actually runs them cross sectionally. It'll do like 1 for the first one. And then like 1 for the next one, and then 1 for the next one, then 2. Like it goes the opposite way. Anyway. What was I going to say? Yeah. I've been away, but I've been writing. Some people said they enjoyed some of the exploration that we've been doing in like the HackMDs, which that makes me happy because that's like where I'm doing my work. And I wanted to. I've been working a lot on SSR recently, but I actually think, given the theme of the stream, I actually want to do a deep dive on deep, which is something that I've been struggling with for recently because of this conversation of split effects. Because for those who don't know, Vue has always had split effects, kind of like React, the dependency arrays. They like back in the day, they called it watch. Even before the term effects came out, Vue used watch. So they had like signals or whatever they called their refs, like their data, and then they had computeds, and then they had watchers. They had like these three concepts, and the watches were split essentially, and it meant that for basic cases like tracking signals, it's like the on operating install is really easy. But occasionally you get that case where you're like, I have deep reactivity and I want to listen to everything below that point. Right? And when you have a combined effect API, you don't need to really worry about it. And like when you're using computeds and stuff, you can just track in. But when you have like split effects, it's kind of a pain to traverse exactly what you need. Like if there's conditionals, logic can be dynamic here. You can only hit certain paths in certain conditions on one side to just do it again when you do the actual side effect on the other side. Like what if it's like do the thing? And this poses some challenges, right? This is probably the only thing about split effects that really irk me. So because deep reactivity really likes the fact that you can kind of discover the reactivity as you're doing the side effect of the process, where split effects kind of forces you to discover up front. So I actually wrote a HackMD about this concept, and then I actually went in and wanted to look at deep because Vue has had this deep ability for ages. Of course, they have a warning on it saying that the performance is bad. And as you know, if part of my decision point of deciding if split effects are viable will have to be that the performance can't be bad. So, set up a test, set up a benchmark, some criteria, and see if we can, if in fact, deep tracking is terrible. And the thing is, I already have a suspicion it is, because this is why Tanner moved off using Solid stores for his baseline implementation. In Solid, it was great; everything was tracking, and we could make the bridge to Vue and Svelte wonderfully. I mean, Svelte 5 wasn't out yet, but conceptually, it was the right path. But in React, the performance tanked because React has no way of doing granular updates. So you'd add a component, you'd have to be like, listen to if anything changed below here, and then let React do the work, right? And whereas in a like reactive library, you just like introduce the data here, and we don't care where you read it. As you progress through the system, we'll make sure only the things that update changes. So like this was like the opposite bad side. Like on one side, if you treat all your data as immutable, React will love you because they're like, yes, we're used to just running marathons. So like they're like, has something changed? Well, yes, it's immutable. If anything has changed at all, you get a new object. So React's like, great, and then they'll diff it and they'll check in, they'll go through and re-render everything. But when we can make that work in like Vue or Svelte or Solid, and especially VDOM libraries like old Svelte and and Vue, like they have the diffing mechanisms built in. But it really sucked for Solid, and it would suck for Vue Vapor and suck for Svelte 5, because we got rid of the need for this this virtual DOM concept, and um, it was really irksome for me. In Solid, this is always really important to me, so I'd come up with diffing out things, something called reconcile. We have approaches in Solid to basically convert immutable data back into reactive data. Like this is the start of my work on projections. It's the same problem as the selector problem. This is such a universal problem, and I realized that. Sorry, where was I going with this? We found ourselves in this kind of like split where either you catered to fine grained reactivity and basically did everything granular, and then like let React have to deal with like messing around with like all this extra steps of like figuring out what has changed, or you cater to React, do a bunch of mutable diffs, make the us do that extra diff work we don't need to do the fine grained updates. And when interfacing with React libraries, I've been used to that second option because like no one's going to rewrite Redux for you, right? And it doesn't make sense if Redux, for example, is built on immutable data structures. But it was kind of disappointing because it would never feel like Solid first or Vue or Svelte. Like obviously people made those other adapters and they're fine with it, but I wasn't. So we tried the other way, and it was just so bad for React because it was such a funny operation. Because not only did you have to track deep, so think about it, like the naive way to track deep is when you get to the store, like the property you care about, like store.user. The naive way is literally iterate over every property in the store and listen to it for the potential that it could change. So it creates a signal, because we create signals lazily in stores, and a subscription for every single property nested however and deep thing. So that's a huge overhead. That's probably unnecessary. And then secondly, even if we know as it changed, React has to know it changed later. So Tanner actually had to clone all the objects as well. I mean, to be fair, cloning could trigger a read. So like you could skip a step, so to speak, because the cloning would also read all the way down. So you just clone, do a deep clone. But like essentially in the process, we'd create like dozens, maybe hundreds of signal subscriptions, and also duplicate all the data. It was just like so bad for React. But it is super useful to have deep watchers on occasion. It is, and especially with split effects, you're kind of forced to. So, is this a problem we can solve? And the answer is yes, and I'm going to show you how when we're done here. Yes, thank you, Edgar. Like the video, subscribe. Do the like, follow, subscribe. Whatever. It helps a lot. I definitely appreciate it. I know this is like the longest part, but where are we at? What test are we doing? We are doing. It looks like we're creating and clearing 1,000 rows, which is the first test. I wonder if the memory test didn't like. I wonder if the benchmark field got ignored, and we're actually doing the memory test right now. Because I figured we'd be done by about now. I mean, we're almost done. I would check, but my computer's running it too fast. Yeah, they are running the memory test right now. Yeah, so my whole attempt to skip the memory test was lost. Although, you know what? Screw this. Since it now runs the tests horizontal, we don't actually have to wait. Before we'd have to wait because it'd have to go all the way through and it wouldn't start the next one until the memories. But because it's doing it the other way, we can just skip. So now we just need to go npm run results. And if we're right, yeah, there's the biggest benefit of the new approach. And we go to localhost 8080 web driver t results to design in text. Although it looks like my alien signals implementation didn't get tested. Wow. Why am I getting such bad results for Vue Vapor on this computer? I mean, I knew the selector test was bad, but this is just crazy. Okay. Well, let's run. It'll be faster just running one of them. I must have. Let's try. Oh, it's because I did dash instead of slash. Okay, fine. Let's run just the Vue alien JSX one. I was hoping Vue Vapor would be like my frame of reference here, but it's the thing is, because I was running them cross sectionally, we can't claim that my computer is running particularly bad for like one of the vertical slashes. It was horizontal. So Vue Vapor's slowness here on my computer is legitimate. Yeah, but oh, do you know what it is? It's because I'm using the version of Vue Vapor from January 25th. My repo's out of date. Oh, that's why. I bet you they've improved Vue Vapor in the last 2 months. Okay, I mean, we could fix that. What test are we on? Swap rows. That makes way more sense. It's you know what I'm gonna do? I've got my other computer here. I'm gonna fast forward my branch to the Vue Vapor branch on my other computer here while we wait, because it will interrupt me while I'm trying to do it, and then we'll pull it down, and then we'll get the latest Vue Vapor in a minute here. Sorry, guys. It doesn't really matter. I could have used Svelte runes or whatever as my. I just wanted like another reference, and I thought since today was Vue Day, we would use Vue Vapor as my other point of reference. Let's repositories, JS framework, benchmark. Sync fork, update branch. All right. Why is it Vue Day today? Evan called this out. No, no. I honestly, I was intending to do alien signals, like basically, the whole time I was off. I was like, what am I going to do? Everyone just keeps on asking me about alien signals. Oh, it's doing memory. Okay. See, that was much faster doing just the one of them. Let's go here, stop the server, git pull. All right, I need to. Oh, that's disappointing. Okay, let's. They're gonna make me undo my results JSON. Actually, though, but it won't. It won't undo my. It's fine. I can yeah, it'll be fine. They'll make me. They're making me redo my results JSON before I update. What is it? What do they want? Results TS. Oh, I guess it's fine. There's a folder that has the results in it, so I shouldn't lose what we already did. Oh yeah. Okay. Now let's stop showing me that. And then what we want to do is go into here and go cd.view vapor npm install npm run build prod. Bam. Okay. And then start. Just pm start. And then exact same for view vapor. All right. I know you guys enjoy like over the years I've come to just love watching the screen just flash in front of me over and over and over again. I know. This is like the long part. We're almost through. The version that Evan posted, I think, had alien signals in it, where this version has non-alien signals in it. So like, I mean, this is the thing. Everyone should always, as I said, because of the variance, everyone should take it a grain of salt. Like whenever you see things posted from people on the JS Framework benchmark, even me on the stream right now, don't consider it official. The only official results are the ones that run on Stefan's computer. If you see anything like this or anything like before it shows up like from a Stefan posting, basically ignore it. That's been always my thing. I've seen people claim crazy stuff and they mean it with the best of intentions, and they put it out and they show it and they do it, and then it ends up getting merged and it actually isn't faster or something. Like it's happened multiple times, more times than it's probably been accurate. So like I would say like if like someone like myself for my local run, like sometimes you have no choice. Like when I'm benchmarking, like when I did that article where I like made 8 different versions of like this benchmark, and then or 4 different versions, then I testing as 5 different. Like there's only so much I can do, right? Hopefully over a number of runs, I try my best, right? I ran everything like 5-10 times. Like I really try my best, but generally speaking, like a random posting of something like, "Hey, I just did an improvement. Here's my JS framework benchmark." No one's going to post anything that's like hopefully like they don't want to risk it like backfiring. So like check your source. Like someone like Evan obviously isn't going to risk it like him posting that and then like posting then the official results being slower. He's going to be as sure as possible before he posts that. But generally speaking, like my experience posting on Twitter when I've like seen like would be framework authors like doing this, many times their results that they get locally aren't yeah um aren't actually necessarily indicative. So you got to be careful with that. Yeah, Mark. Sorry, I because of the benchmark, I can't like click on anything. It'll start like if I click on my screen where I have the chat, it's actually going to move the benchmark when the window opens up next. Will open up on that screen. It'll just like it has this like it was wherever my mouse is the focus is. It's going to like open the window up. But the answer to the question, yeah, Vue 3.6 is moving to alien signals. We're here kind of we looked at alien signals. We saw the performance. We saw the kind of the elegance of the code. We're actually trying right now to see if alien signals makes much of any difference when it actually comes to a rendering benchmark, which is why I added Vue Vapor just for fun as like a um, third reference point. This sounds like my pet peeve about posting Lighthouse screenshots is Jay Larkey. Yeah, I mean it's like the people who post desktop mobile speed scores instead of uh, and they don't use like web page they don't use like web.dev or whatever. They like literally do it on their local computer. I mean that's actually two problems. The local computer one is this problem, and then the instead of using like web.dev, and then the uh using desktop instead of mobile is like using the Cellx benchmark to talk about reactivity. Okay, we hit memory. Yeah, for some reason the benchmark filter is not working, but let's see if we can do npm run results. And then hopefully, if everything went well, we will have our results. Okay. Guess what? Guess what? Yeah. Yeah, this is actually kind of funny. I mean, it's not funny, but it's exactly what we thought would happen. When I changed the signals version, it actually made the Vue.rx JSX faster than the proxy version, which is not surprising. The alien signals version is actually, you could see that it's slightly faster on many of these benchmarks, except for select row, but we couldn't do the selector for it. So the difference here, which is basically nothing, like we could probably get this on a different run, between, oh, this one's faster, alien signals and Vue 3.5 is essentially smaller in this benchmark than the difference between select row, which already is basically nothing. Just kind of put in thing. And yeah, I mean, it's interesting. The other thing that's interesting to me is these are running the same version of Vue. I wonder what the Vue Vapor implementation is. Are they using nested signals or are they using stores? Because I guess I never optimized my Vue RxJS implementation until just now. And I imagine they're using stores because, like, why would you? Oh no, they're using shallow ref. They are using shallow ref. Yeah. They're using shallow ref. So this is optimized. So, I guess the only way we can make this fair is if we move create selector from this. But if you look at it on every other test, it's very, very, very close. So I would, and actually slightly in favor of Vue RxJSX. So DOM expressions and Vue Vapor are probably, as I imagine, very close in performance, almost indistinguishably so. This one has an advantage because of the selector test, but the impact of alien signals basically made no difference in this test. What if I'm using signals to render my 3D game on the server? Well, that's it. That is interesting, right? It depends on a couple things, right? Is the graph actually going to be your slowdown, or is it going to be the async, like the my gut? And I've seen this. That's the reason why even when it's hard when we talk about React and we talk about like three fiber and how they like had to use like concurrent mode and all the like things to improve the performance, like those like demos that Paul Henschel did a while ago with the cubes and all that kind of stuff. The problem is React re-renders everything, but we're already in a zone where we're not re-rendering everything. We're doing fine-grained, hyper-sensitive updates. So people have used Solid to make games like that because they're like, wow, like it's instantly better than using React for it, even with all the tricks you could do. Like React, you basically have to ignore that state library. You're just using its JSX. But even then, they're like, I'm not sure with the signals implementation is fast enough. Now, arguably, you could say that it might be possible that alien signals performance difference makes a difference, but I wonder if the abstraction or the overhead of the actual 3D like models themselves are going to be more impactful. Like the part of the reason that this is so huge is the DOM is expensive. Our 3D mesh is expensive. Right. There's no template cloning there. That's true. All of these mechanisms are using template cloning. In any case, I mean, this is not conclusive by any means. But it is kind of showing that like when looking at benchmarks, you have to look at what you're testing, right? What this does suggest is that alien signals has better cleanup than Vue 3.5 reactivity that's in both of these. You can see that it's higher. Like this is the same problem we have with old Solid. Alien signals has fixed this. Another thing that we can kind of see from this a little bit is, yeah, actually that's probably the only thing that I really see here. That you can see places where removal is involved, like replace rows and remove rows, can slightly better for alien signals. But these are still well within variance. Obviously, create selector has a big implementation different. It is interesting though that alien signals improvement over Vue 3.5 actually on its own made selection better. This is actually probably one of the most interesting things. So we didn't see it here because the selection was already good, but alien signals propagation here, I imagine, is one of the larger reasons why this is actually better without create selector. So there is this is a fan out scenario, right, where you have one selector doing 1,000 rows. This is probably pretty legit. I mean, and you could say maybe this is what Evan's talking about. Like they already were making, just switching to alien signals actually does improve that. Then again, this difference could also be a difference between DOM expressions and Vue RxJSX here, right? Or sort of Vue Vapor. This could be just that the way we render in DOM expressions is more tailored to select row. Anyway, I don't know if we need to make many more conclusions from this. There's no way to register manual cleanups. At least that I figured out how to do. The problem I had was that I was using a different mechanism of maps to do create selector. This is like the hype. I have like 3 or 4 different versions of create selector, and in current Solid we actually use or in 2.0 we actually use a slower version of create selector, which uses projections, but it's still faster than doing it naively. And the problem is we have this cleanup function. We have to be able to register stuff in the effect scope, like so when the computation reruns, it needs to clean up, and I couldn't find a single way to register cleanup yourself. Like obviously you can set up an effect scope, they have ownership and auto cleanup, but there's no way for the end user to register cleanup. So alien signals does have ownership, which is awesome. It's like very important concept. It's like the baseline that surplus S.js introduced and what Solid is built on. The only thing is they haven't really exposed that capability to the developer. So I wasn't able to make this in user space. Whereas I was able to do it in Vue RxJS because their old reactivity didn't have an owner scope, and I actually just hacked my own owner scope in, and then basically handled the cleanup myself. Like, you can take something like Alien, or I mean, Alien's fine, but you can take a base reactive system with tracking and hack ownership in. That's how I've been building these demos over time. So yeah. Anyway, I think that's it for this segment with alien signals and view and all that kind of stuff. I don't know if anyone else has any questions about this, about the benchmarking or methodology here. I'm not going to submit this because honestly, I had to cut out a bunch of features to make it work, and then I'd be re-implementing them. And my gut is Vue Reactivity 3.6 will just take care of it for me. It will wrap alien signals and do all the stuff, which means that Vue RxJSX will continue to be good. I might be tempted to submit the signals version in though, because it's actually, it might give Vue Vapor a run for its money. And when they submit the alien signals version, it will also get faster in theory. So we could be in a world where we could see if DOM expressions versus Vue Vapor is faster. At a core, and that might be an interesting place where we can like see if there's trade-offs to the way that I built the renderer versus how Vue or Svelte did. Like, this is the first time Svelte's a little bit more locked in, but Vue Vapor without the Vue part and DOM expressions are both, my understanding is like, bring your own reactive library, right? And it's an imperfect thing. Like, I was very tempted to just axe DOM expressions because I could build stuff more specific for Solid. But as I said, I basically built my own version of Vue Vapor like five years ago. So it's kind of cool thing just to have for, experimentation like this. Anyway. Yeah, you could, if you use the React. Okay, very brief thing. One way of doing the selector thing is using the reactive system. Like, in a kind of normal way, you can kind of dynamically create the signals. Like, you make your own signal projection. So like, you can essentially, as you iterate through, you can just create signals. And again, I don't know if that's slower here. It might have been like I don't know if it's slower than just doing it naively, but you can make a signal for each row dynamically, and then basically use that to do the selection mechanism. What I did with Solid way back was I found a way that was faster, which was using maps, and then I'd keep references to the reading node, and I would call them. Most reactivity is like, we'll call you, essentially. Like, you'll schedule it and then they'll call you. I came up with this mechanism that reversed the flow of reactivity. So essentially, if you look at the code for the JS framework benchmark, and I'm not going to use Vue because of their templating language is not whatever. Or actually, I have to use Solid in this example to explain it, or the one we were working on, alien signals. Oh no, not that one. The other one, the Vue RxJSX. I just need to use one that uses the selector to show what I'm talking about. Yeah. Let me show you. What I was doing essentially is selected doesn't do a reactive read. It actually collects this computation, this effect, or whatever this is. It collects the binding context, but it doesn't actually create a dependency. So each row, when it gets created, actually, and with this map set approach, doesn't create a signal, doesn't create a dependency. So the dependencies and stuff are empty. So it literally just passes right through without that overhead of creation. And then, I mean, there is an overhead because we do create the sets, and sets actually can be expensive, but a set is going to be cheaper than a signal because signal is like multiple objects. And then essentially, when the selector triggers, it uses that information where it, like, said the ID here, and the computation it's associated with to just directly call those computations. So it bypasses the whole tracking system and reverses the flow. This was my first approach because it's very difficult to make projections and selections performant. And to this day, this is still the fastest approach I've come up with, but it's very specific. And what I've done since with 2.0 is generalize the approach to projections using stores, which will work for literally every problem of this nature, instead of this one, which really only works for selection and multi-selection. Because I'm not. It's a difference between me paying. I basically, if I went to 1080p on StreamYard, I'd have to pay like 4 times as much money. I know that's something, but I don't actually make money from streaming at basically all. YouTube changed the algorithm and stuff. Even though I charge stuff and have ads and I have Twitch, whatever, I make probably. I don't even get enough money to pay for my StreamYard off streaming. So yeah, obviously I'm not doing something right, but I that's not why I do things. I just. Okay, so let's talk deep, right? That's what I was prepping you guys for here. We're going to talk about deep. I think we're good on this stuff. There we are. We can close down. Why? There's something really weird going on where I can't, like VS Code just doesn't want to shrink for me. Anyways, yeah, I don't think I'm even going to screenshot these results. I think they speak for themselves. I mean, we're not surprised. I know I make a big show of it and spend like 40 minutes building this thing, but we kind of knew the answer beforehand, even though I honestly, in truth, didn't know the answer completely. Like, I haven't done this before. It just, some things are kind of obvious. Okay, so let's look at deep. Yeah, view, watchers, deep. Because see, they have some notes here. Let me blow this up. But they're like, I love views docs. Like, honestly, like, because watch works directly on an effect. You can just pass a function, makes sense, and then new question, old question. Solid's new create a split effects basically would work like this. Actually, you know what? Before we do deep, I want to do one more thing. Let's pull up the hack MDs. Come on. Let's sign in with GitHub. They're going to be like a jerk here. It's funny, they won't let me use I have like an authenticator, but they're instead going to text me. Okay. All right. Yeah, let's forget about SSR. I have 2 new things on SSR for now, but I want to talk, before we talk about deep, I want to talk about split effects, because as I said, React has split effects, right? They have a depth array and they have thing. Vue started from this place of watchers. If you actually look at their code, when they go almost straight into here, and then later they're like, oh yeah, there's a watch effect somewhere down here, right? Oh, there it is. And guess what? You can do it all together. It's sometimes convenient. Oh no, it's not even watch effect. It's because watch effect is still like that. Or sorry, no, watch effect here. It's all one function. Yeah, right. Makes it a little bit more convenient. Blah blah blah. Both allows to react for side effects. Main difference is they watch reactive dependencies. Watch only tracks explicitly watch sources. It won't track anything else. Watch track on the end combines dependency tracking side effect when it fades. It often tracks every reactive property. This is more convenient and typically results in terse code, but it makes reactive dependencies less explicit. I have to admit, early in one of the big changes I made a knockout at my company was I switched it all to, I called it sync. but I switched it to we did all our effects with explicit dependencies, not our computeds, but all our effects, because it made the code way easier to trace. So we actually, my own wrapper on top of Knockout that the company used and set as a standard, we used something like Watch back in, like, as I said, 2014-15 period. I'd had enough bad experiences with ping-ponging reactivity. So like, this is not crazy to me that Vue kind of approaches it this way. React approaches it this way. Solid didn't. Because at a certain point I was just like, well, like in the JSX, it's going to be just all mixed. So let's just do it. And now with the new signals libraries, Vue adds watch effect, ruins followed the suit. And I find myself in this really awkward place where I'm like, we actually should split them, right? And I did a whole stream about it. But then I got to this point where I was sitting there on break late at night and just going, people are just really going to hate this. Like, no matter what I do, people are going to really, really hate it. Like, the amount of people arguing against split effects on that one stream I did was immense. I spent like an hour and a half arguing with people about it. And it was just like, it's like one of those things that has to be. But so I was like, okay, can we just not split effects? Like, is this an option? Right? Right. And don't get me wrong, I'm in a boat where, we probably we'll keep a watch effect too. I think it's more primary, like a Vue's thing, though they have watch and then it's watch effect. I think it's more primary to be split than not split. But offering both probably is still reasonable, except yeah, this is where my thing goes. I'm like, is it okay to offer both? Right? I know I made a big thing about splitting effects the past few months. Sorry, did I copy I might have copied the wrong share link. Yeah, I copied the wrong share link. My bad. Let me put the right one on. Sorry. And you know what? It's completely the correct conclusion. Just like you shouldn't write to signals in pure computations, just like a whole bunch of other similar rules, the rules you follow the rules, you get great results. The React core team has a term for this. They call it falling into the pit of success. They are not the originator of this idea. I want to look into this a bit. Obviously, Jeff Atwood isn't even, but his blog from the mid 2000s is amazing. Just a side note, just some of the stuff, like streaming SSR, the Lost Art, also wrote that article. But basically, he's just talking about like the problem with C++ is it does a terrible job protecting you from your own worst enemy, yourself. Like basically, you want developers who don't know what they're doing to kind of find success. If your software is too hard to use at a certain point, it's on you. That's basically like the gist of it, right? But if the React core team is guided so much by this principle, why do so many people have a hard time with creating performant and optimal React apps? Well, because even if it is one of success, you're still falling in a pit, right? I think this is kind of important fact. Like falling in falling to the pit of success is raising the floor. It's not. It doesn't have. It has nothing to do with the ceiling or like. So in general, this is a good idea. If people find software too hard, it won't be very useful for them. However, what I've witnessed over the past few years is the rules can get so strict that people can't make sense of them anymore, right? Like there's one thing to love the Rust borrow checker, but there's another thing where because then you won't get in trouble. But then there's another thing where it's like you literally don't know how to write code anymore. React is optional for a company with 1,000 developers where one code can't kill. Well, yes, this is the pit of success, right? Because you have 1,000 developers, no one can. If everyone's just falling in a pit, they don't die, right? Right. Basically, they are pretty good at making sure that if you write some code, it will generally work. It does, but it says nothing of the quality of that code. The problem is over time. But the problem to get there, you have to follow rules. Is what I'm getting at. Like you have to be like the rules of React, whatever, because you can still break it. Like it's still possible to follow, like for things to break. So you, in order to, they just set really, they set guardrails, really high guardrails, but you still have to follow those guardrails. If you try and go around the guardrails, stuff still won't work. The guardrails just make sure that like you fall forward instead of falling backwards, right? And at a certain point, these kind of systems, I think, inevitably get to a point where the rules get so strict and so piled up that you're not talking about a pit anymore. You're talking about like a conveyor belt of success, so to speak. Like, and it's not like success in the good way, the success in the pit of success way. Like you're basically now kind of on rails to probably fall off. You just have, but you have no control of it anymore because like the walls are so freaking high on either side. So what I'm getting at, sometimes people want to do what intuitively makes sense, no matter how incorrect or detrimental it is. Ryan Florence was actually on Twitter. I wonder if I bookmarked it. Let me see if I bookmarked it. I didn't, but he was literally. Let's see if we can find it. Ryan Florence. He was on Twitter complaining about React. He posts too much for me to find it right away, but it was about Flush Sync. It's funny, like if I go through my notifications, probably like far enough back, I'll find it. Sorry, like I have nothing important here. I don't care if you guys see this. Ryan Florence. I wonder if I can just like type his name in here and get to it. Oh, doesn't help when we have same name. Like never gonna find it now. No, just never gonna find it. This is never gonna find it. It happens to me all the time. Anyways, he's complaining about Flush Sync, and he's like, I'm done with using tools like this where like I can't make sense of it anymore. It was like the perfect example for the point I'm trying to make, and it bugs me that I can't find it right now, because it had to do with the whole synchronous execution thing. Yeah, it was like around this time, but it wasn't that response. Damn it! What it's like it deleted. Did he delete his tweet? It was definitely April 10th. This another like. Oh, okay. There it is. Found it. Over a year later, I'm wondering why this is still so dang hard. I left Ember over the stuff. React is just as hard now. I'm ready for a client rendering model that balances these kind of tasks better instead of hyper focus on performance and pedantic stuff like idempotency. Yeah, Brian hates auto batching, which Solids hasn't to this date done, right? And so does Dax. There's a lot of people who hate auto batching, and I don't blame them. It's one of those things where it's like, yes, it's the correct thing to do in most cases, but it's also like, I was trying to figure out what, like, is he okay writing Flush Sync, or does it like miss a gap for him? But does he? Okay, let me see if is there a specific. Yeah, okay, yeah. So I did find it. Okay. So like, this mentality, like even with someone as prolific in the React community as Ryan, you kind of feel it, and this is what I'm trying to get at. So like, even if I know that it's wrong, can we do this for people? I always hate when I make those compromises, but it is a question that I think is worth considering, because people want to be able to just write code and do stuff. Sometimes the guardrails, the pit of success is just like, it's great. Like, it creates that beautiful system that works great for people. But sometimes it just, like, if they can't reason about what their code's doing anymore, you've also lost. You can't make the rules more complicated than the problem that they're trying to solve. So this troubles me. Right. I had this discussion also with someone in the web components, still replying months later on my web component thread, and they were talking about how they'd come up with this perfect system, blah blah blah, and they were like splitting client and server, kind of almost like some web components are server only, which is something I haven't really thought about much. And then with client components, and I'm like, but then you're not SSRing the client components, and they're like, each has its side, yeah, but I'm like, effectively the solution isn't like empirically as good. Like, there's places, and he's like, yeah, but I get to skip all the complexity, and it's like I couldn't even explain. Like, it got to a point, it was hard for me to explain just how much better the other solutions were on every vector, because of the complexity of understanding all that goes into it, like to take the whole journey up. This guy, for his case, had found a good solution, so he should keep at it. Obviously, he was arguing to me like he'd solved the universe, and he clearly hadn't. But like, I think that it doesn't matter whether he hasn't, or whether I understand how much better things could be, if we can't cross that gap together. Yeah, but it becomes guardrails when you're like, as you keep on doing the tower up, like, it should be defaults, but like, maybe like React is such a good example, but just because how twisted the semantics are. I know it's funny because they call, signals and us twisted, semantically, but React is just way left field compared to how a lot of people learn to program. Like, don't get me wrong, people who learn functional programming first, like if your first programming language is Haskell, maybe elements of React or might make more sense than that. But most people learn really bad mutable imperative coding, and the React model is like, flips it on its head. It convinces hydration is a real problem. Yeah, it's funny. Yeah, pretty much. I mean, I think that's what it comes down to. But we've probably bashed on web components enough this stream. I mean, it happens accidentally. It's too easy. But maybe we should be. I need to be more conscious of it. It's just like one of those things that just kind of accidentally happens. So yeah, let's just talk about this a bit. We'll get into deep after this, but user effects don't participate in rendering, right? That's been the new revelation with 2.0 when I did this stream, is that we can make user effects independent of suspense and error boundaries. So we don't need to know their dependencies up ahead. So we can combine them, right? Transitions, all that fancy stuff, effects that, like, you writing to your third party program or whatever, writing some logs, don't need to worry about that. Sure, if things aren't mounted, they need to be held and all that kind of stuff, but generally speaking, you don't care about all this like split time garbage when you're writing your user effects. So why should I force you to care, right? Right. The trade-off here is, with lazy computation, some pure nodes won't run during the pure phase, as they won't be read until later. I don't know if you guys remember, I did an Excalibur a while ago. I don't even know if I have it in here anymore, but I was comparing the timing of execution. Yeah, it doesn't look like I have it in here. It was on my old computer. I was comparing the execution time of React and Solid, and saying how, if everything's lazy, you can run some nodes for the first time during the effect phase, or you can run some nodes in the pure phase. If you split the effects, you make sure the pure stuff always happens, all of it, before the effects. You can't accidentally perform some effect before reading something pure. So, like, again, Ryan Florence, I don't care about pedantic stuff like idempotency and you know what I mean. Like we know that when weird bugs appear and people are like, what's going on? We have to justify our position. It's way nicer to justify your position with like, look, this is a clear way of how this will always work. But the consequence of having a system that's explainable and follows rules is that you do care about crap like this. So like, like at one extreme, you have like for our current system, we have things like React. And then the other extreme, we have like Svelte 3. Svelte 3 was just like, whatever feels natural, it will get there. And the problem with that is that it had one of the least intuitive reactive systems ever. That's why like they were so stoked on changing it when they changed the ruins. Like Svelte 3 sometimes didn't work in a way that was like consistent, because it's like it was just like just let it slide, whatever's easiest, whatever's natural. These aren't extremes you can just choose. You end up almost always in the middle. Close your eyes and hear some use Svelte, yeah. Right. But okay. With later copies, pure nodes won't run on the pure phase as they won't be read later, but you can use them to read from the DOM. You shouldn't really, though, but pre-render measurement to post-render measurement is something we do like with flip animations. But you could make it work with like two types of effects, like a render for pre and a user for post, where a single split effect could do both. That's fine, assuming measurement guaranteed to run before render. I mention it because I recently hit an issue with the order reactivity tracking caused havoc on effect execution order because dependencies got read first higher up, causing that branch to notify and queue first, even though effects were declared in opposite order. So, yeah, effect order is something you can't trust. So the scheduling of the pure before the effect actually safeguards you a little bit. But in general, we really shouldn't be relying on the order effects. You can rely on the front half running before the back, and the back of render before the back of the user effects, but that's about it. But with that enough rules, you probably could still do flip animations. So this isn't a deal breaker. It's just me kind of talking through it. The other thing to consider is render effects run both halves immediately initially, so refs from later aren't there. After initialization, the front half creates refs, so the back half of one declared earlier could conceivably get it. But that's no different than today, I suppose. It suggests that most element augmentation will happen in user effects, which is an interesting note. It means that like when you're like in user space adding stuff to the DOM, it's generally not going to be using a render effect, which is interesting because you think rendering was where you do that kind of stuff. It's just kind of understanding that. Explicit tracking with any depth feels awful. This is another thing. Now, a store only issue for most part, but it's real. If a signal holds an object or an array, it is understood the whole list needs to be swapped to trigger change. So this feels fine. But once it can be updated granularly, it's awkward. Like pushing an item or swapping an index won't trigger it. If it did, we'd never see the granular tracking. Yeah. So what I'm trying to say is, okay, if list is a signal, and sorry, this is just supposed to be a function. It looks like I'm like returning an object. Oh no, I guess that's not an object. That is a function. When you put braces, that's returning an object. Anyways, my point is, if this is a signal, the only way to update the signal is to replace the array. Like if this is a list. So if you have added something to the list, you actually have to immutably replace the list, and then you rerun the function. This is the truth of it. There's no way because it's immutable. Like a signal has a value, change value trigger. Now, if this is a store and someone updates a single property, you're not accessing that property there. If this was like, list 3, then yes, when list 3 changes, you'd expect this to run. But here, this is not access to property. In fact, if this is store, this doesn't work. But if you wrapped it in a function and called, list, it basically would never update unless someone replaced the whole list. And when you're doing fine-grained updates, like pushing, it would not trigger. So the problem is you can't just assume deep. because if you assume like that you can't just always notify deep. What I'm getting at is if someone is listening to 3 and someone pushes 5 on the end, you don't want this to trigger. You can't just assume that anyone who listens to this array wants to be notified when you push something to the end. So like it's tricky. You can't just come up with a single rule. You either over notify things that are only listening to specific indexes or specific properties and objects, or you'll under notify and just like not trigger anything. You have to opt into this behavior. So what did I say here? You wouldn't expect adding to the end of the array to trigger it. Yeah, okay. Now stores technically create separate signals to track the whole array, so they can have either behavior, but we can't assume it is top level in what we return from the front half, right? We don't know. Like, what if someone returns an array or an object array? You can't just assume what you get here is like what you want. What you want is what I'm getting at. It has to be explicit. Stores for the most part aren't async. Is a good point. Except for getters, they aren't derived, and in that case, that isn't deep. One thing that I kind of realized while working on it is like, if stores aren't async, if you can have async projections, but then it's the source of the async is coming from how you're deriving it. So you can say like, hey, I'm reading this data and I'm projecting out this thing. And in that case, every property of the projection is tied to that asynchronicity. So it's not like, as you're exploring through the depth of the store, you're going to suddenly hit something randomly async. It's either going to be able to process the store on a whole or not, based on whether it depends on something async. So from that side, there is a saving grace that just like kind of an aside, that if we did have a combined effect, it's the first property you accessed on that projection is going to cause it to throw. You don't have to worry about getting like 90% through the process and then suddenly hitting something async. So this is an argument for why stores probably aren't, or projections aren't, an argument against split effects. Sorry, just a tangent, but it's just that generally speaking, the whole thing triggers async or the whole thing doesn't. It's not a granular consideration. Yeah, I mean, that's how the solution ends up working in the end. But from the end user perspective, it's colorless. So like, if you split effects, you never get to see, you never have to witness the color. When you put them together, you suddenly get this, like, write something that you think is synchronous, and then it suddenly behaves differently. You get this mess, is kind of the problem. Anyway, so deep signal bags are the only place where async gets us in trouble. Reading at the top of effect probably is reasonable enough advice. Picture deep traversal async airing out midway is probably pretty pessimistic. More than likely, it throws async immediately. So what I'm saying is, if people, when they wrote their combined non-split effects, just accessed all the variables at the top, even if it just means accessing the first property of the store or projection, they're probably not going to run into trouble, right? That's sort of what I'm arguing here, right? I think it's possible that I might have overstated that people would get in trouble. Like, I think that generally speaking, so far both of these arguments are saying like, it's better to use split effects, but it's probably fine. I mean, this is kind of a pain. So why wouldn't you just use a joined effect in this case, right? Because the only way to solve this is deep. You need deep, and it needs to be explicit. It can't be automatic. So you're forcing another API to do this with split effects, where it just works automatically with joined effects. Error handling plus async throwing is awkward. Okay. Once you split things, you need to consider source errors different than effect errors. Yes. Not that combining them is great either, right? Yeah. So what I was saying is, once you split them, there's a difference between this side erroring, because let's say it's not available, or you have async data that's errored out, and your effect erroring. Whereas when it's together, they all kind of bundle together and you just handle the error yourself. The problem is, if async throws promises effectively, like React, you can't just use normal try catch in your effects if they're joined. If they're split, you know that it's only going to throw async on the left side, and the right side is normal code, exactly how you expect it. But if you combine it, now you have to be aware that async can be thrown in the middle of your like random code that has no idea about the reactivity system. We have a try catch helper, kind of like the one that Theo proposed on stream. It's kind of funny. He's like, I always use this thing. And I was like, that's funny. I actually added that to Solid 2.0 a few weeks ago. But there's this tension, right? That async brings to surface. If you view your effects as oblivious to reactivity, right, which is probably why you want to combine them. You have stores with properties that you access, and just like pretend it's a normal JavaScript object when you use a third-party thing. Like, if you view your effect as oblivious to reactivity, you would normally be able to use try catch in your code, right? Right. But like, it works with split effects because the reactivity is stripped, right? But if you're conscious of reactivity, then all the effect code becomes part of the system. You can't arbitrarily expect third-party code to work. Like, there's this real awkwardness. Like, the reason that people want to just jam it all together and pass stores into random processes that don't know about reactivity is so that they can just accept normal objects and pretend like there's no reactive system. But then normal things like try catch won't work in there, so that's broken. But on the flip side, if you split it out and make it clean, then you have to know the reactivities there. You have to like go through the effort of doing deep or like tracing the path you want ahead of time before letting it work. The thing is, when you split, you truly have an outside of the system that works exactly without any weirdness, like as native JavaScript works. So there's like no winning here. It's like the argument you make to combine them in terms of these deep stores is the same argument that basically cancels it from an async standpoint. Deeply nested reactivity blurs the line, and you kind of want it to, but it also doesn't work. So tricky. Okay. And this kind of brought me to my fourth point. I hope you guys are following so far. It's that combined effects want to tear, probably. It feels less disruptive to have an effect trigger and bail out every time something is loading. So this is an important point to make. And maybe this changes a bit in the future, but the changing of the loading state is something that triggers things to rerun on the pure side, because some things might be observing the fact that it's loading, which means that new async is going to trigger like when we are tearing, we don't care about loading and we bypass it, so loading states don't affect it. But when we're not tearing, every time something goes to loading, we have to retrigger the effect, right? Because then that thing can't process, and we have to notify, because we need to, some new reactivity that comes in has to be able to know, hey, I should block. We have to get all the way to the leaf so that something listening at the bottom. So we basically are stuck in this really awkward place where I showed this example before where I was like, oh, we don't know what order A, B, or C runs. But when you consider the loading triggering timing after initial run, it's not just like the 5 combinations I talked about. You might see like A, B, B. Like, you might just see like things popping in like even crazier orders if you don't do tearing. If you do tearing, at least you know that like it'll always get the previous value and you can kind of predict it a bit. Like, once you get past that initial like, oh, this might step down, you can basically just say it's always the latest thing. But if you didn't make it tear, which is what my default was, and which is what I was aiming for, this is even worse than what I said in the past. Well, that's what we do right now. We only queue. Well, the problem is that's a chicken and egg, right? Right now with split effects, you only run the effect when the async is resolved. It doesn't tear, because it doesn't matter how many times the front half runs. The back half only runs when it resolves, and you know this because you have the dependencies up front. But here, you can't only queue effects when async resolves unless it's like all async, because you can't know what this effect needs until you actually run it. Right? Like, you can't make that determination because it's the running of the effect in this combined state that actually tells you what it depends on. So like like this isn't just the problem with the order of A to B C console log or what side effects gets runtime, but unnecessary work as things come in and out of sync. Yeah, like what if each of these console logs is actually side effects? Sure, you can properly write it with cleanup, but you might recreate and break down the side effect like multiple times, not just in the chain of its order, but multiple times because of the loading state of something else loading causing it to do that. Like it just creates a whole bunch of work. Don't queue if a loading goes if a known dependency goes to loading. Yeah, I mean that would reduce the numbers. Like because but again, it's very specific because now you'd have to like know what type of read or like what type of dependency is being tracked for this. No, I get what and to be fair, tearing is what I'm talking about. Tearing is it just always reads the previous value, unless there's a new depth. So, I mean, what you're describing is not that much different than tearing, other than it doesn't actually tear, which is kind of cool. It's just very specific. It's still a mess, though. I guess there is a world where that's solvable. I'll grant you that. So after the initial load, the situation in the log gets worse. What if A is resolved and we trigger B? A might run 2 more times. This is an argument for keeping unrelated effects separate for sure. But what I'm getting at is even if they aren't completely unrelated, your conditional effects might execute in more ways than you expect. Yeah. There was an exercise that I did in the Solid Discord like a month ago, so I'm not going to really dig it up, where someone gave me a really complicated set of conditionals and asked me how to write it. And it took me a minute or two to figure out how to break it into like 3 separate effects. Because what you want to do with conditionals is isolate the effect and the cause with split effects. It works way better that way. And then each expression is shortcuttable. But a lot of people don't write their logic that way. They don't think that way. It was like that Dan Abramoff response on my signals thing, where he was like showing like this imperative logic where he was like updating something in a for loop in the middle of a component. And I was like, that's just dumb. Just write it declaratively and everything works better. That was an easy thing for me to in the situation to write. It just was a little bit verbose. This one actually took me thinking, and I don't think developers necessarily think in that way. Even though if the final code will be cleaner and runs more effectively, it's like how people have a hard time writing like state machines, like with their logic, because it's a lot easier for people to see like if this then this, and like seeing like an imperative chain than just being like these are the rules. If you can set up the rules though, it's very 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 powerful. But yeah, it's kind of a mess. So yeah, this is a mess. Even reviewing this, it's way clearer to view stuff as an inside outside the reactive system, but granular effect is a superpower overlapping stuff allows. But maybe this is a superpower that should only exist inside. As hard as I try to make the argument, combined effects really just are a negative. Not even considering how split effects do things like forcing right after purity, clarify the stale cleanup problem. And if resumability is ever a thing you want, split effects can run the depths on the server without even running the effect. So like these are all things that split effects do uniquely. I was hoping this exploration would give us room to keep create effect as is and introduce split effects as a different primitive. We could still do that, but it's pretty hard not to slap a big deprecated label on this one. It just isn't good. If split effects are clearly the way to go, I need to come up with a reasonable solution for nested reactivity. I will explore that next. Yes, they definitely have this additional mental overhead. There is no arguing that point, which is why I like wrote this whole mess of a thing, because I agree. The problem is the alternative is horrendous. Yeah, sure. I will bite. Like this is why. Yeah, okay, because you guys are talking about the teardown problem. This is another thing that's solved automatically by split effects. Yeah, there is clearly. For us, the main reason I project would be the explicit which I probably think they're misguided to do so, but I'm just some guy. Yeah, no. Yeah. Yeah, but it's the not simple cases. Stores are really an important thing, and nested reactivity is our superpower. It's like the thing that's unique about these solutions over React. If we were only using signals and no stores, you could definitely use something like React. I agree with Rich in terms of like it's harder, and it's like this problem. This is why I was talking about this. It's like often with React, you get there and you're like, man, it's the right solution, but like no one's gonna like this. There is this additional, like, especially with deep tracking, that's where the thing is. So that brings us to the next topic, which is like, okay, if we're gonna solve this, like, obviously, if we split effects, we don't have to worry about this. We don't have to worry about this. This is fine. Literally, this is the biggest thing against split effects. Explicit tracking with any depth feels freaking awful. Okay. Now, I'm not gonna. Can we make this any less awful? That's part of the problem, and this gets us all the way to like the view watch, because I went there and deep watchers. When you watch directly on a React object, it will implicitly create a deep watcher. Oh, so that's cool. So they know that when you pass a store directly in, that they automatically do it because they support both a function and non-function form. I never thought about doing it this way, but so because there's implications, but the thing is, this won't. In this case, the callback will only fire if it returns a different object, right? Which is the situation that we're in. Basically, if some object swaps, then it updates. But if you go some object dot property equals 5, this is not going to fire. However, you can force a second option by doing a deep true, right? So that's used with caution. Deep requires traversing all necessary properties with watched objects and can be expensive when using large data structures. Use it only when necessary and beware of performance implications. Right? So I was like, okay, how terrible is deep? How is it terrible? How terrible is it? So I went in and I grabbed view reactivity and I created a data structure with 15 properties in an array of 100 objects, and each property has an object in it, which has an object with 15 properties, which is an object in sync to a depth of 4. And this data, this construct, via my arrays and char code and all this, because they're all ABC, whatever, took about 86 milliseconds. And then when I fed it into a watch expression, and for this one, I didn't realize I could have just done, I didn't need this deep true, review automatically hands it, but I set it for immediate. So because they're lazy by default, I think they're watching, and flush sync so that I could like time it. We basically see the situation where it takes 86 milliseconds to make, but to deep track this object on creation and update takes about 2400 milliseconds, so about 2.4 seconds to deep track. So yes, that if you understand, or 2.5 this run around, if you understand what this means, is it means if you came across this object, and this is an absurdly large object, don't get me wrong, but if you came across this object and you created it, it would take this long, and then every time you update it, like someone like updating this one properly, A, B, C, Z, doing these like fine grained little updates, it's taking 2.5 seconds to upgrade. Like, this is absurd. Obviously, this was not designed to handle such a large object. But so I mean, we could move a like, what's more reasonable amount of data? We can move a layer off, so maybe 3. 150 milliseconds, 150. I mean, that's still locking 10 frames of FPS per change. I'm going to go with this as kind of like really, as I said, use with caution. So I was like, and there's an option with Vue. I think they say that you can say how deep you want to. You can how deep you want to go with Vue. Deep option can be a number indicating the max level of traversal. So you can optimize it like this. And I was like, man, that might be actually the thing that I'm most afraid of. If we get to a point where people are like trying to like think of optimizations for this, like, oh, I only need to listen like one level, or two, like kind of implicit untracking. I was just like, okay, this is awkward. This is definitely awkward. So I started trying to like brainstorm what I could do. So as often would you be surprised, like most things, there's a solid primitives for this already. Somebody else in the community has already done this. So as I said, that's the thing I love with Solid. You just, have a library or an idea you want to do, and someone's already made it for you. Great ecosystem. Sorry, I'm being a bit facetious. People always make fun of our ecosystem, but the truth of the matter is, like, the number of times that I find stuff that I'm looking for is surprising. Anyways, the deep, they have track deep, track store, and capture store updates. So track deep, reading this, is basically just a really dumb way, like naive way. They just iterate over through every single property to make it work. So I took the same test and I was like, okay, let's do this with Solid, right? And let's go here and let's do track deep. Okay, give it a second. And I'll refresh this so we can get the fresh things. And with track deep, wait for it. It takes a couple seconds, right? It was the update is about 2,500 again, and the init about 2,900. It's actually a little bit longer. It looks like, but it's basically the same numbers I got from Vue. So that gives me a hint at how Vue is handling it. Is basically the naive traversal. You just go through, check everything, walk through all the properties, and track it. So that's not great. Obviously, with smaller data, we can downscale this, like we saw with Vue, down to 100 milliseconds, but that's too much. Let's keep the giant data structure. So when I went into solid primitives, someone in the community, they'd solved something called track store, a much more performant alternate track deep that is utilizing memorization and specific store implementation of solid stores. You should consider this instead of other track methods for large stores to update rapidly or track many effects. So what they're leveraging is, the way we have a way that we can trigger arrays. I mentioned it earlier, without on like index change or whatever, without tracking length. Sometimes, like, I realize that sometimes you want to do it. So every proxy in solid stores has an optional, again, only if you use it, additional signal. So every object array has an additional signal. And if it exists, when we update the property, we'll update the object and notify it. Only things that listen to track, like and it's a shallow one depth track, are basically arrays in stuff like our control flow components. You'll see $track being used. But these guys were like, well, what if we just track all the way up? So instead of our data structure having, like, if you look at this data structure that I was making here, this naive one where it's 15 properties and then 100 and then depth 4, like it's like let's get a calculator. So it's like 15. Where's scientific? 15 to the 4th times 100. Yeah. So the naive version here is creating 5 million signals and creating 5 million subscriptions. What if instead of doing that, we basically only tracked at the per object level, essentially? so that the last object doesn't care about those properties. It's the last layer. So we're already 15 to the 3. And yeah, so in a sense, it's not much of a fix. But if you think about it, it turns it into 15 to the 3 times 100, which is only 330,000 subscriptions and signals, which is a definite improvement here, and sizable one. So let's switch to this one. I'm going to comment out that one and just do this. And you can get this today in solid primitives. And what you're going to see here is that deep structure now is taking 152 milliseconds to update and 275 milliseconds to create. So it's almost it's basically 10 times faster on creation and 20 times faster on an update. So, you know, again, if we made the numbers like a little bit smaller or more realistic or more of that, now, you know, this example where even when we made it smaller in the view example here, where we're like, oh, it's 158 and 172, at least with this approach, it's only about 10 milliseconds to update when we shrink the data down. So this might be acceptable, and you can get that today. But I wasn't satisfied. Right? Like, if you give them this API, people are going to do dumb stuff. And I would love to actually be able to give them the API without the warning. Right? 10 milliseconds an update is too close to 60 milliseconds. Like, you won't get 60 frames per second here. Right? And I'm like, these guys figured this out, the solid primitive guys, in third-party user land, which is freaking amazing. Can I do something better core? So let's go back to our giant data, right? Because what bugs me about this is creation takes 87. We're okay if that happens, but it's weird that the update is more than the creation, you know, in the init every time. Is there a way that we can do better? And I came up with a deep helper in Solid 2.0 that I think does just that, where the initialization time is close to the data creation time. This has been jumping around, but then the update time is 0. What? 0? That can't be right. No, it's definitely calling update. Sorry, sometimes the console logs get thing like that. 0 to 1 is from the effect. They get squashed sometimes in here. Let's run it again. Oh, it's 0.2. Basically less than a millisecond. And the reason why this approach is so fast is because it creates only one signal and only one subscription instead of 300,000 or 5 million. So how did we do this, right? Because this isn't even the small data set. This is the giant data set. If we go back to like, oh, maybe this is more reasonable, we get a situation where the initialization takes about 5 milliseconds, and it's again about the same cost as creating the data, and the update again is still about 0, right? So it's basically, it's not per store, because if per store could over notify, you have to start thinking about how to solve this problem, right? If you're not going to traverse, the challenge is the only way to not create a billion signals is to say, in the same way we create one signal for track, I added a $ deep signal. So it's at the level, the thing you pass to deep right here. That store, that's top level store. If I went store.data or store.data.a, whatever I pass to it, every node in the store has the potential to have a deep signal, just like it has the shallow track signal. So that part's straightforward. The way we solve this is that when any store gets written to down here, we walk up to parents and check if there's any deep signal, and if there are, we notify. Simple, right? Well, not really. It can be simple, but there are some challenges here, right? There's a reason why there's still a creation cost. When I was in the process, the real breakthrough came for me was actually thanks to some of you might know him, Fabio, who works on Vobi or Bobby, I don't know how to say it. Member of our community, always quick to point out. Give him a shout out properly. Quick to point out performance issues in Solid and how we mess everything up. But framework author, 900 stars on GitHub, so this is legit. It's another reactive framework, similar to Solid. Works similar to Solid. Yeah, great. No VDOM, blah 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 blah. It's just lighter. It's I don't know if it's necessarily lighter weight. He basically doesn't do the JSX transform. That's like the claim to fame, and his API is slightly different. But he's been doing a lot of the similar work, and he had solved this problem because I was already thinking doing this parent thing, but there was kind of trade-offs because okay, let's say you have a weak map where whenever every child back references as parents. See, when you have a proxy and you get up here, how do you know who the parent is, right? Yes, this approach works like that. Yes, because because you put the watcher at 0 0. So then if 0 dot a gets updated, or ad or let's put more arrays like 1 2 3 4 5 6 all the way whatever down, it walks up the parents until it gets to that node at 0 0 and updates. Yeah, both is age function. Yeah, but built around that use case much better, like better than our version, admittedly. So where I was sitting at is like I realized when I was working with Tanner, I was like, Tanner, I solved this like over a year or two. I'm like, I can use weak maps to backtrace the parents, because like the first thought you have here is, what if you use the writing path, right? But like the access path on right, because you can go S data 55 A B Z equals 2, then like, because B came from A and A came from 55 and came from data and came from this, you could trace back and see if any of these have deep on it, you can fire. That's actually incredibly fast. The challenge is, what if your object's in multiple locations? This is the difference between like Redux and a reactive nested state, is that Redux, and I was lamenting over this a lot when I was doing like diffing with stuff, is every time you update part of the store, you clone the whole freaking thing. You not every object in it, but you clone everything along the path. And if something's referenced in two different locations, well, unless you also go and update the reference in that other location, it stays the old one, and now you have the new one in the new location. Whereas in a reactive store, if you update the object in one place, it updates in the other place automatically. That's expectation. So the problem is, if you have something in two places and you initialize the store or do something way, or you don't walk all the way deep into it, you might update something in one location that you've never traversed before in a different location, and then that wouldn't update. Solid signals. Let me see if I can open this up. Let me go in here. Sorry, actually, the tests are probably the most indicative thing here. Store. Um, No, I'm testing deep, right? Oh, did I not commit it up? No, I did a release. I did a release. It should be in store.t. Oh, it's in utilities test. That's my bad. Yeah, sorry. This is where it is. I can like show this an example of this, so you can kind of see what I'm talking about. Axe deep updates. Where is the setup here? Yeah, see, create store, first nested shared reference. So I have this thing, shared reference, in these two different locations, right? First nested shared, second nested shared. If I create an effect that deeps on first, and then I write on second, how would these ever know about each other? Because you can think about it. If you've never linked, like you initialize it like this, you would never have linked up this tree. You have to traverse all the properties to create the backlinks to the parents. And I don't want to do that, generally speaking, on creation. It's one of the performance overheads that we were doing a VDOM UI bench a few weeks back. I was talking about how I'd come up with a new diffing, immutable diffing under the hood approach. We were doing unwrapping eagerly in Solid 1.0, and it was tanking our performance. It's funny, pre 1.0 we were really fast, and then around 1.0 we got slower on diffing. I fixed the diffing problem by not walking through everything. So we don't want to walk through everything on creation to create these backlinks. We're not doing it already anymore. That was one of the big updates that I'd made. But we need to create it. So how do you solve this? Well, because if you look at it, if you go deep store first here, you're starting here. You're not like, they're not related. They're not sharing part of the tree, right? So how do you get these to notify? And what I ended up doing was, even though we don't create async, or sorry, we don't create signals and subscriptions all the way up, we do, when we call deep, traverse all the nodes to create the backlink of the parents, which was expensive. It's not nearly as expensive as any of the other solutions that we looked at so far today. But like when let's go back to 4 here. It was around 90, or it was still expensive for creation, but the same cost as it costs to create the data in the first place, which I think is an acceptable metric. The problem was, then every single time when I came up with the solution, I was like, it was faster because basically every single time users not using this feature were not impacted, but every single time we update the effect called deep, it would essentially run this again originally, because it would basically retrack, because it's like, look, something could have changed. I need to relink up with all the parents again. I don't know what could have changed. And that meant that while it was a significant improvement, updates were still, in this extreme case, about 90, which is not acceptable. Obviously, again, if we go down to like 3, updates being 5 milliseconds is arguably okay. But I didn't like this. And Fabio came in and he's like, look, my updates and creates are 0. It's like, what? Well, he didn't solve the path problem. He did something smarter than track the writes. What he did was, he's like, if anyone anywhere ever accesses the store along that path, we'll register it with the weak map. So he did at least handle the case, as long as you like access first somewhere, like access like this somewhere else in there, it will know. But if you haven't discovered it first or whatever, it's not going to trigger, which he felt was a reasonable trade-off. What I ended up doing to solve this was combine both approaches. And the way I did that was, initially on creation, go, again, not for all stores, just things that do deep, do the traversal. But write a shortcut in the traversal that if it ever ran again and it hit something that had been processed, it just skips. So that's why after the fact, it knows it doesn't have to run that pull traversal. It just stops. That's why it's 0. But then you're like, what if stuff's changed? What if there's new hidden deep properties you don't know about? Well, what I did, which I wouldn't have done as a generally speaking, but because you don't want to make write expensive. When people write objects, you don't want to go be doing the traversal either. That's, again, one of those performance optimizations I did. Well, what I did was when you go to write, it walks up and notifies deep, right? If it finds something, then it goes, okay, well, then I'm actually going to go and build the parents for the children of this value that I'm building. But if it doesn't find anyone, it doesn't bother. So basically, only users of this feature are impacted by the overhead of using deep. But in a case like this, the initial setup is expensive because the data was big, and the write is cheap because you're only setting 2. Now, if we were setting an object, maybe is slightly more expensive. If you're setting giant objects every frame, yes, then you would be back to paying similar to this initial cost. But my assumption is with deep is that you're not, like, if you're at a point where you want to track everything in here, deep, and you want to replace everything every frame, then why the hell are you using stores? Like, it's the reason you want deep is there's like a discontinuity, right? Like, there's like, you're doing really granular updates, but they could be anywhere, right? Like, or like it's the impedance mismatch. It's not like, because if you're doing big updates and you're doing big tracking, use a signal. So anyway, the end result, I mean, I'll leave this up to the reader, so to speak, is you can basically decide, like, Voby's approach is smart in that it's almost always 0, but it only works if you've actually traversed the path. This always works at the small cost of like a slight initialization. It's already significantly faster than the other approaches, even before you add these kind of optimizations. And I think, as I said, most people, like even this object that we're using in this version here, where it's taking 5 milliseconds and basically instant updates. If I pull out our calculator here, yeah, it's actually this case. It's still an object that contains 337,000 properties. I think most people using deep, like, even that is a stretch. Like maybe. And in this scenario, we're talking about sub 1 millisecond updates. Well, I mean, sub tenth of a millisecond, but we're talking about nothing is that expensive. That being said, in this scenario, track store is not that expensive either. It's like 3 milliseconds, and but naive is still expensive. It still won't get you your 60 frames per second. So you can argue that the worth of this optimization over the track, over the middle ground, might not be worth it. But in theory, I could sleep comfortably knowing that if people do really dumb stuff, the performance will never get that bad. Yeah, but only the types of, if something listens to it deeply, yes, they will be slightly slower, but only for the types of writes. It's based on the size of the object that you're writing. So if you're, it's like if you're replacing the whole array of objects with new objects. Like if they're existing objects, not expensive because it's shortcuts. It's literally if you're like creating new data every um every on the update after that frame. But yeah, it's basically only impacted. It only impacts people who use the feature essentially, and portions of the store. Like you're not going to, like, basically the overhead that you hit is is the overhead that you see from the second number here, the update number. So like in this case here, it's this, the overhead is this 0.01 or whatever. Like it's not the expensive overhead, it's the cheaper overhead, so to speak. But yes. All right. Anyways. Okay. Yeah. Yeah. It's just gonna be the numbers in burst, right? How do I do that? Yeah. So create store like this, and then s.data equals data. Yeah. See, the numbers have reversed now. This was the worst case, right? This the 3 or the 4? This is the 3. Yeah. So now the init is 0 and the update is 5 milliseconds. So if you're adding what was this one? 337,000 prop object, like nested prop objects. It takes 5 milliseconds to update. Yeah. So it's basically just the inverse thing. As I said, maybe this trade-off's not worth it. Maybe we should always be 0 and just expect things that people haven't traversed to not to notify. But I think this is the fact that this always works is pretty beneficial. Yeah, and it's, as I said, it's like what, like 30 more than that. It's like 40 times faster, even on the worst case, than the naive approach that you would just do yourself, or like which ships with Vue or whatever. So I mean, no one should be probably doing something crazy like this. As I said, if you're swapping this, like if this was your thing, you should be using a signal, right? Like if you wanted to deep track it, I mean, there might be a scenario, but like if this was what you were doing, like you're like, yeah. Anyway, okay. I think I've got 2 more hack MDs, but I'm not going to do those today. I think we're good to wrap up with a little This Week in JavaScript, which will not probably be terribly long because I have not been keeping up on it, but there's a couple topics. So let me quickly get myself ready for that and give everyone a chance to take a quick drink of water, myself included. Wake up, shake those arms, see if you guys are still alive, right? I probably lost a lot of you. I apologize. Is anyone watching on Twitch anymore? 25 people. All right, let me get quickly set up here for This Week in JavaScript. As I said, I haven't been on top of things, so if you guys might have topics that I'm not familiar with. So let me see here. I went on break March. Yeah, I had a baby who arrived 9 days early, so I was kind of caught off guard. So essentially, the timing, is a little bit. Sorry, just bookmarks. All right, we got to go back to. Sorry, there we go. March. All right, and then finally, solid. All right, here we go. Yeah. Okay. Beautiful. Okay. Yeah. Thanks for the congrats on the baby. Yeah. Yeah. It was. I was like, what? Like we were ready, but like it was also like sudden. So at the same time, it's like I wasn't like as prepared for like work stuff. I kind of just like dropped work immediately. Anyways, let's talk about this week in JavaScript. Okay. So I'm going to start as I usually do with a little bit of solid updates because you got this is your chance to see some of that. Let me see here. Just want to make sure. Yeah. Okay. First thing, all the big news coming off our last stream, as you know, TanStack stuff. Jack Harrington took basically no time getting the TanStack CLI working with Solid.js. So he's like, want to try out Solid.js in your app and don't want to rewrite everything? Module Federation has you covered, and the create TS Router app starter for Module Federation makes it easier ever. So basically, he's basically created your migration kit. He's like, you can basically start a project that's written in TanStack in React and TanStack in Solid simultaneously and have them sit right next to each other so you can migrate your stuff across with the same APIs, the same, the same features. You get to use TanStack, query, TanStack, router, all the good stuff. And you can literally just have your existing app and your new app, like literally like just sitting next to each other, all working together. But yeah, okay. Yeah, I'm not a fan. You guys all know that. So it's like a necessary evil sometimes. You know what I mean? Like, if you can use it and then get rid of it, then it's worth it. That's kind of the problem with web components, right? You go, oh, they're a great migration tool. I'm not tied to any specific framework. I can have all 10 on the same page, and then you'll never get rid of the web components, right? That's the sorry, I'm dissing red. Why is it so easy to diss web components? Like, I'm sorry. Okay. You probably call it stores 2.0. Yeah, I mean, I have so much more. There's so many cool things on the stores, but yeah, this is yeah. There's so much cool stuff. Anyways, let's keep on going. Sorry, yeah, we covered this last stream, right? That cursors written in Solid. I actually had like Misco reach out to me from Quick, and he was like, "I was talking to the cursor guys. They want help debugging a problem." I was like, "Oh, okay." Like, I just didn't realize people talk about AI and React is so dominant in that field. To find the tools that people use actually written in Solid is it's funny because people are like, I won't use Solid because AI isn't good at generating solid code. I hear those complaints these days. It's kind of like it's done. Everyone's staying React ever, and yet the people making the AI IDE are using Solid. I don't know. Maybe that says something about the developer, not. Yeah. Anyway, we did talk about alien signals the first the first hour and a bit of the stream. This is like Remix flaunting ChatGPT using them. You should do more of that. Okay. Yeah. Yeah, this month in Solid, Daniel's always on point. What else do I got here? You can now build your Solid app with Turbo Recall and style it with Tailwind. Yeah. I just love seeing like this is a Vercel setup. Like I love seeing these like pre-made templates. It's just getting easier to build this stuff. What's this? Fastest framework now with the quickest database. That works for me. I don't know much about this, but Triplet, the full stack database. Is this another one of those like sync things? Triplet. How do you spell it? Triplet. Full stack database. Yeah, sync one. Yeah, it's a sync engine. Well, I mean, sync engines like us, and for good reason. I said this, the store stuff that I was showing off today, when you could like, there's so many elements that, in terms of like diffing and projections, that yeah, it's so funny when I like the create selector thing. For the Evan call it or whatever. In like a year, it's gonna look like the silliest thing, like because like literally where the whole everything is going. Yeah, it's all good. Yeah, yeah. There's that call out again. Yeah. See, I know stuff's been going on in the community. I'm sorry, I just haven't been able to keep on top of it. It's my fault. I do the Twitter, and David does the Blue Sky for Solid, and I have not kept up. So let's switch around. Okay, yeah. First of all, Vite documentary. I am stoked about this one. And yes, I've been in a lot of these, obviously, but this trailer is one of my favorite trailers for them, and just the crew of people, and just like it's I there's some jokes about, I'm actually the narrating the clip. I didn't realize that they kept on putting pieces that I was talking about in between the other people talking, even though when I actually said what I said, I wasn't actually narrating it. It just they kept on putting my sound bits in between the other quotes, which is worked a really cool thing. But I can't wait for this to come out. Vite is so vital and important. And Vcomp is live this year, and yeah, I mean, I got invited. I don't know if I can make it, but I really hope I can. If not, there'll be solid representation. I will, worst comes to worst, record a video, but I am very stoked to there. Yeah, everything up would be. I'm the historian. Yeah, Valibot V1. Awesome work, Fabian. I I mean, it's funny because this is kind of like the RS pack thing. I think that when faster solutions come out, we should give them proper respect to kind of figure out space. The challenge with Vite is it's like the meta framework. It's like the layer on point, and it doesn't care what's underneath. It's like building up this whole stack of things. Maybe now that it's Void Zero, there's actually going to be like battle because the lines will actually be drawn. But like previously, Vite was in a position where like they're like, we'll just use whatever's fastest or whatever's best, which makes it kind of difficult to compare it to any other specific bundler technology and stuff like the environment API and all this. It's cool if others are saying like, I can make this but smaller, but yeah, I mean, there will be a tipping point probably, but right now, this is mentioning Valibot because Zod is an example of this. This is 1 kilobyte to Zod's 15 kilobytes. This means that this sort of schema validation on the client is actually viable. I would never bring Zod into the client. It's crazy. I'm like 15 kilobytes is, like one of my GraphQL user, but like 1 kilobyte is definitely something. And Fabian did an incredible job to keep the thing small. I still don't know if I'd bring validation onto the client, to be fair, but if I were to, this is how I would do it. As I said, he's done amazing work over the year, and I'm so excited for him to hit his version 1 release. This is really quite an achievement in terms of improving the status quo, and that's what I was saying, like with the RS pack thing. Like it's if there's always going to be tools that push the boundaries a little bit. Like, and to be fair, like some people might view Solid like that for Vue or Svelte now. Some people thought we were that for React, but like where we push the ideas and drive it, and then bigger, more popular solutions kind of adopt it. But like we didn't start our life as something which was a better version of something else. We built and carved out a new space, and I think that's what probably makes Solid a little bit different. It's harder when it's like X but in Rust, or you know what I mean. That's like a different kind of thing where yeah, I guess there's a difference there. Zod Mini is 3 kilobytes, only 3 times bigger. But yeah, I mean, this is what happens. Like this kind of improvement, like 15x or whatever in size, happens by a major architectural shift, and then if given enough time, others will copy it and latch on, right? But it took someone actually doing it. This isn't, I do get that, like, our, like, switching something to, say, Rust or something like that is like 70x faster kind of situation, but it's like it's hard when there's so much competition. At least in his case, Valibot kind of came out and that was their unique thing, and it's only really Zod that you have to consider, right? Yeah, I started the stream earlier today. Alien Signals was like the first 2 hours. I'm actually like this is like my new 5 o'clock sort of thing. I'm this is the last. We're kind of winding down here. We're doing this week in JavaScript right now. What I got here? Nobody got this. It's fine. I didn't expect anyone to. This is just for you guys' reference. This is a California poppy. It's a flower that grows where I live in San Jose. We're moving to Oregon actually, so this is probably the last year that I'll be seeing this regularly. But it always blooms at like the end of March and the beginning of April, and which timing wise is significant to me, especially because my son who passed away, his favorite color was orange, and he loved flowers and gardening, and this is just kind of like an remembrance kind of thing, which I talked about here. So yeah, a lot happened in the past month or so, but that's essentially the gist of it. I saw this flower last year right after the events, and then I saw it again this year, and it's kind of like symbolic for me now. Kind of like I know the red poppies are the sign of remembrance for like Flanders Field and all that kind of stuff. So yeah, what's this? The honey pot guys rebranded, and they re-merged because, like, I don't know if you guys know, these documentaries are like they all feel the same, but they were actually one company that split into two companies and now have apparently remerged back into a single company. It's kind of interesting because I've been along the journey for them this whole way, but yeah, so yeah. JS Nation in the US, New York, I'm speaking at, and I will be there. So, I've done a lot of European conferences over time, and now with young baby and stuff, I don't want to travel as much. I'm very happy to be able to speak at some US conferences. I've always had a harder time getting into them. So, yeah, if you're in the US, in the East Coast, New York, next, what is it, November? Yeah, I'll be there. Oh, you're working on the custom render stuff, like the universal. I'm not gonna lie, that's like 90% copied from Vue. Vue's custom render was like, I was just like, what should a custom renderer be? And then I just was like looked at Vue, and then I kind of took their concept and then applied our fine grain like rendering, like the I mean, it is like Vapor. Like Vue didn't have Vapor, but yeah, it was kind of like I looked at Vue's API surface and then implemented it using our fine grained, thing before Vapor existed or whatever, like using DOM expressions. So like I imagine it's almost like replacing the clone template with a few other details. But that's cool. Anyway, so, I mean, that's one of the benefits of this change. When Svelte was completely compiled, it was actually harder to build like Svelte for terminal or 3D. Like Rich made specific versions of the compiler to do that. Now that you have signals in this setup, building universal stuff, kind of like the way React does, where you can just target any platform, becomes actually very, very straightforward, and you don't need a virtual DOM. So, I'm not surprised by that. It's been very useful for us. We have like solid 3, so it's kind of like 3 fiber, but for solid, people have been making 3D games for solid for the last couple of years using our extension. Obviously, Svelte has one similar, but now it doesn't have to be specific. It can be like a generic one. That's pretty cool. Yeah. To be fair, like I didn't know what I needed, so I just looked at the surface area view. If you look, the internals are mostly just like any other of our the DOM expression libraries. What do we got here? Vibe coding. I don't have much to say about vibe coding. I think I talked about it earlier. It's like the complete opposite way to where I code, but I actually think most things should be product led. So like it's reasonable to me. It's just funny when you see like it's also like the epitome of like what's wrong with AI. Like where like you just know you're going to end up with the complete garbage, but it doesn't matter as long as you create the right product. You know what I mean? So it's not a way to do engineering, you know. Important that we can friends. Yeah, I've been sorry, I just caught that. I've been there are some tech personalities and people in Portland that I've in the community there. I'll be interested to see how moving there is. I to be fair in San Jose, I've been actually pretty isolated. I went to San Fran a little bit, but Jack Harrington and Jason Langstrom are both in Portland. So yeah, I don't know if there's what the tech community is Portland. I guess I'll find out. We talked about this. Bar streaming is live. Okay, cool. And then let's look if I have any bookmarks. All right. We talked about these. Okay, I'm making bold claims. Very well if you don't like it. Oh, Delaney exposes alien signals. I guess this is on point. Let's see if I have a couple minutes to talk about this. I watched this morning for the first time. I just bookmarked it before without watching it, and then I think I bookmarked it again because I didn't realize I didn't watch it. It's interesting. Basically, he was the premise, at least what I got from this video, and it might be worth people watching if they want. I can link it in the chat. Is yeah, let me think here. Sorry, new comments on my old thing, but basically the gist of it is he's like, look, why are you doing all this traversal and all this complicated stuff when literally if you know the dependencies you just run the thing. And it's funny, that was like the premise that we did when we started building Marco 6, but I think most cases fixed dependencies like compiler based, like that's how Svelte 5 or 3 and 4 worked to a degree. And Molina, which as I said is the fastest on the JS framework printer, that kind of reactivity we already showed like improvement isn't actually going to improve like rendering that much. But conceptually, if you just know the depths ahead of time, then you're not doing all this like song and dance, so to speak. There is a bit of a question on traversal. And for Marco, they actually decided that because of the traversal dynamic, it was actually easier or more straightforward to actually keep a runtime thing, but then compile in places where they knew that they could be strict. And I think Svelte was talking about similar optimizations, except Svelte could only do it at a local scope because, you process a single file. Marco creates some crazy cross-file thing that literally tracks the reactive dependencies across your whole application and outputs the smallest possible bundle and is resumable. And it's basically insane. And also not released yet. Marco 6. But the thing is, it was funny doing that exploration, building the prototypes, building that stuff. Generally speaking, the challenge that we couldn't, one of the most powerful things in reactivity is stores. And like we talked about them a ton today, and deep tracking and all that stuff. And it becomes very difficult from an analysis standpoint to know like what updates when you have an assignment to some nested object somewhere reactively that can be passed around in piecewise, like to actually track the reactivity of things that can be broken apart into little pieces and then actually at compile time. Because how should I put it? Like even with, let's pretend we have split effects where we have like, or split memo, split everything, like where we actually have explicit dependencies that don't change. And you just know that, first of all, those dependencies have to be like signals themselves, right? Because you don't want to run them. You have to know that they are signals, right? From a compiler standpoint. So like arbitrary functions don't work anymore, which is kind of like the keystone of what I built with Solid, right? Unless you're kind of pushed to wrapping stuff reactively, like turn into a signal or a memo, any kind of arbitrary expression. Now, if you had enough control of the system, as like Marco did, and presumably what Delaney's doing here at DataStar, you could get around that for the shallow case. But for the nested case, I think it is challenging. I think dynamic dependencies that change at runtime are one of the pretty crazy claims here. But the gist of this, as I understood it, is it's 60 times faster in like these crazy in our reactivity benchmarks because it doesn't have to do any of the processing the reactivity system does because it's not processing stuff at runtime. It literally just has fixed steps. And I think it's funny. Dominic from Inferno actually had a version of these benchmarks like a year or two ago. And he's also Svelte 5, where he actually showed me, he's like, look, this new reactive system is way fast. And he was doing compiled stuff like that. Obviously, in the end, like that's not what they ended up doing because like it only works in a single file, etc. But whatever the way they did it. So like they have optimizations, but like for the benchmark purposes, like they ended up not using it. But he showed me incredibly fast results that like beat everything else at the time. I don't know how that compares to alien signals, but it's kind of like we're going potentially really far off a deep end in terms of performance here in a way that doesn't actually impact anything. And there's a risk of sacrificing the dynamicism if we give this up, especially where things do make a difference. Because stores, like we were showing with Deep, I mean, if you can do smart things with stores, you can change the execution characteristics. Obviously, that was Deep was optimized in doing dumb things with stores, but like the thing that React can't do with its compiler is have some data at the top, update one thing fine grained somewhere else in the tree anywhere, and have it update one thing else. Even with the compiler, if React needs to get back down the tree, it has to cancel out its memoization along that path. It's immutable, and it has to rerun those components. And even though some of the stuff on the leaves on the other side are, cached or memoized, it still needs to redo that work. Fine-grained reactivity, being able to kind of transcend and run through your whole app and then update it pinpoint, is something, whether it's nested signals or stores or proxy, whatever that we're going to use, is a superpower that is very hard for a compiler these days to emulate. If someone does solve that, though, hats off to you, then you've done it. But on the surface, just saying like it's 60 times faster because the upser fixed is kind of like, yeah. I mean, like there's not, it's kind of like the obvious thing. Like it's a thing that crosses your mind and then you're like, yeah, but we realistically can't do that. Or as we scale it up, this is going to be a limitation that doesn't work for us. Or it's going to actually cause the performance push to be somewhere else. Anyway, we are top on Hack News. I haven't been able to, but I see I am on screen. Yeah. We're just talking about the 60 times faster thing. Is that what's on Hacker News? Because if so, that's kind of like fake news. Yeah, exactly. Like if you shorten the pipe, then you're not gonna need it. Oh no, some article. Okay, cool. Yeah. So, anyways, it's interesting and very in topic with what we're talking about again. If you can change the paradigm altogether, then you can, in theory, make these kind of monumental shifts. Like if this shift, as I said, the shift I don't think has an impact like on rendering, as we showed earlier, because we used alien signals and it basically made no difference. On the rendering side. But if this kind of shift can suddenly unlock performance in a different vector or angle, then these are the kind of things that push the whole thing forward. An example of this was fine-grained rendering. Before fine-grained rendering, a lot of like even the fastest VDOMs were slower. We improved performance 20-30% in an actual like visible way. Sometimes it's a matter of finding the right benchmarks. It's interesting. As I said, if someone can solve nested reactivity via compilation, there would be an opportunity for this. Anyways. So our 60% we no op. Yeah. We worked with them to make alien 2 times faster. Nice. And our intern is faster by more. See, that's the best part about it. If we can actually find new optimizations from the shortcutting, that is the win, right? As I said, it's ironic in a stream where I basically said that the performance aspect of alien signals is probably the least interesting, but I count that as a win. Okay, let's see here. React server components are nice in there, but 5 years in, it just isn't working out. It's been fun. React, you taught me a lot. Have fun with the React server DOM. I'm done. Where are you going, Michael Jackson? Yeah. So is he going to Preact? Yeah. 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 This. Yeah. This is like the checkout of React path. People, I, it makes sense. If you like old React and you just want to keep it small and simple, Preact is a clear choice. It's not breaking the bank. It's not changing anything fundamental. It's not. It's a little, maybe a little bit faster than React. It's not a bad place to be. Oh, this is a little interesting side note. Class actually works. You don't have to use class name. I guess the TypeScript doesn't work, but apparently they do support Reactive agreed to rename class. They said this in April Fool's joke, but in reality, this is apparently real, which makes sense. I mean, it kind of there's no reason not to support it, probably, except for two ways to do the same thing. I've been learning that's a terrible thing. So we've actually yeah. Solid 2.0 combines all the class stuff, class list, class name, class whatever, into a single property. No more of that. This is a cool article. I don't have time to go over it today. But Eduardo, I worked with him at Netlify. Very thoughtful, working on the platform team there. I, I think AI is something we always think about, but if I remember the gist of it, he's talking about like how much easier it is to go from like inception to the end point. He's saying like you're building more builders or creators this way, right? Which is cool, right? You lower the boundary every time you do that. You can get new, unique, interesting things, which is really the win, right? Because different people think different ways, and if you get enough people thinking different ways, you can actually that's where things shift. Like we were just talking to Delaney about like approaching the reactivity problem a different way. That breeds more innovation, even if not the direct thing beside besides itself. Like it leaves a wake, and I think there's value there. But I don't think AI is a topic that I'm going to talk much on stream or I really care about. Everyone's like, I saw this week, everyone's like AI this, AI this in the future, and it's just like it doesn't impact what I do at all. So like I'm aware of it from the standpoint of like what people can use these tools for and how they're approaching things. But it's like I mean, it helps me fill in when I did Chat GPT or sorry, Copilot helps me fill in when I lazy filling out some code. But often I just like when I'm doing a lot of things, I have to just throw it away because I read the Copilot code and I go, I see what you think you're doing, but I'm working a completely different zone here. Like Copilot only knows what it's seen, and I often build things it's never seen before. So yeah, it's interesting. Ultimately, yes, because I think stores will allow the break apart like the reactivity granularly enough. And we've been working on derived stores as well, like projections. So this idea that a combination of diffing and piecewise writes at different locations will be able to propagate changes in the most granular and modular way, which will allow real-time systems, especially if the source information coming across is granular, like piecewise. If we know like, hey, this is updated, like the database is like you added this one row, if you can propagate from start to end on like the diff information, you have the ability to just like skip diffing. Essentially, it makes things like React seem completely pointless and obsolete. So like the key to it is if we can keep that granularity throughout, then like I think this is why I've spent a lot of time looking in these zones at these solutions in this thing, because there's a real natural fit here. The funny thing is, if your morph layer works good, I'll be coming back to you. I think this is the secret to HTMX, or the diffing between the markup of the static parts, is a problem we're going to revisit again in the future. I think partials, like we have with HTMX, could be a part of a really important solution. I just think it's the most primitive. Like I don't. It's a very primitive part of the solution. So like if these morph DOM things are very effective, I would love to get in there and use it. It's just, I couldn't leave them to their own orchestration. I don't care about the HTMX directives and all that. It's the actual HTML diffing mechanism and DOM diffing that is going to be important here. Partials are a thing, but they have to be controlled or orchestrated in a certain way if you actually want to have certain properties true, especially in terms of solving things like double data. And if you want to ensure that people aren't doing dumb stuff like causing waterfalls. This is an area that I do think actually needs significant guardrails. So it's a design question problem. But if the technology, this is why I pay attention to this stuff. If the technology involves in the meanwhile, I think it's very, very interesting. Okay. The thing is, I've been working with the guys that have taken over, and we've gone our own road. That's awesome. Okay. Durable objects are free tier. That is cool. No one understands or knows how to use them, but they're very capable. That I'm hoping this encourages people. That's awesome, Sunil. React Conf is back, not just Next Conf. Yeah. I mean, to be fair, I think they did this last year too, but there's a time period where everything didn't feel like it was React anymore. Good on you. Johnson doing his part. I have to imagine that he create Selector here. As we saw using, and let's see, there's something fancy he was doing with the code. We saw these results on stream today, that alien signals would improve the Selector code, but I don't know if they could improve them that much. I wonder if he did something like create Selector. If he did this natively without create Selector, I'm impressed. But again, always skeptical of results that aren't official. This is, if there is a naive way to solve this problem, I am very interested. Yeah, and this is the same video we talked about. Okay, I hit the end of the list. That's awesome, and we're not bad on time. I have to be going. We've been going for over 5 hours now, so yeah, I don't know. Does this new time work for people? I know it's a little earlier. I overlap a bit with Primogen, but I don't think our audience overlap very much anyways. Every time he drops people here, I say something absurd to piss off those back end people. So yeah. Great for you on the reason. I mean, fair question. No, not really. It's like the benefits of the React compiler you don't need. Like Solid just works that way already. Or I mean, technically it works a bit more performantly, but it's also like maybe arguably slightly less ergonomic. But yeah, I mean, the thing is, the type of compiler you get is probably syntax based, right? Anyone who hasn't seen it should probably see Solid labels by Alexis, and he made this project about 5 years ago now, and basically he has these things called $sign with called labels, which have $sign and then the name like signal and effect, and then you just use the variable directly, and then you don't have to like call it as a function or do dot value. And as I said, he made this about 5 years ago, and I've never, I've seen this in Svelte. So basically that is the sort of that is the sort of thing that where I could see people doing stuff. Like React compiler doesn't solve split effects or dependency eraser effects. They just solve memorization. So like we've had this for 5 years. I just don't see the big deal. Otherwise, like, I guess we would have had our own labels instead of runes, whatever you want to call them, 5 years ago. You know, if there's even solid color, it'd be like Marco 6. I like the transparency. I like the rules being consistent. I saw this 5 years ago, thought there was issues like where it made it hard to teach things. Svelte seems to 5 years later seems to think differently. I I I think it fits better with their philosophy. So I guess we'll see how that goes for them. But personally, yeah, it would be like Marco. Yeah. So far, we've been able to do everything runtime, and which is crazy when you consider the async stuff. Maybe there'll be a time, but right now, I like the fact that like literally you just compile JSX. That's it. That's all. It's just like Reactor stuff. All the JavaScript code is yours. Compiler could be to convert dynamic depth static process with that small performance boost that probably doesn't matter. Yes. That's. I mean, the trickiest part is you need it like Marco where you can trace the depths back, I think, because locally, I don't know if you're going to see that advantage very much. It's when you can, yeah. I mean, I've looked at a lot of compilation stuff. Like Solid does some cool stuff if you look at it. Even though we work only on the JSX, we do stuff like inline expressions in certain places or pull it concept. Like there are things like that. I did look at one point thinking like, oh, maybe I can inline components and make templates larger, within the same file. Like if you could tell that stuff was used a certain way, then you could like because the larger the template, the more you can clone it, there's performance improvements there. But I mean, I don't know. Yeah. Anyways, I'll have to check this one out later. I gotta go. I'm over time, so I think, yeah. Thanks for everyone joining the stream. I appreciate all of you spending the time learning with me, sharing your ideas. I mean, this is how things happen, right? We talk, we communicate, we try ideas. People like Alexis making solid labels 5 years ago, or what was another thing that was 5 years ago on stream. Yeah, I made a like basically Vue Vapor 5 years ago too. So like just being able to like constantly push the boundaries. I love this part of my job. Obviously, people have real apps to build as well, and we have a bunch of people working to make that a reality. But this time on stream is when I get to have fun with you guys, and I really really appreciate it. So thank you. You guys have a great weekend, and catch you soon. Maybe not next week. Maybe the week after. I'm doing basically like every second weekish. We'll see. But you have a good one. All right.